Champs of Examsnet, welcome to the question series of Examsnet. I hope this series of detailed explanation is helping you a lot. So in this session, we are going to discuss the chemistry questions from NEET paper 2019 and we have 45 questions here. Okay, so let's start the session. The first question is from the chapter hydrocarbons. Okay, and the question is the most suitable reagent for the following conversion is. Okay, so we can see that on the reactant side, triple bond is present, that means this is an alkyne, and on the product side double bond is present, so this is an alkene. Also it is written cis 2 butene, that means an alkene. Okay, so how do we obtain an alkene from alkyne? By partial reduction with hydrogen. Okay, so hydrogen is used to reduce alkynes into alkenes, but that will be in the presence of palladized charcoal that will be deactivated with some poisons. Okay, so let's write it down here. Alkynes on partial reduction with calculated amount of dihydrogen, that means H2, in the presence of palladized charcoal. That will be partially deactivated with some poisons. And one of the examples of such poison is quinoline. Other possible poison can be sulfur compounds. Okay, so it will give us an alkene. So out of the given options, we can see in the first one dihydrogen, then palladized charcoal and quinoline all are used. So this is the correct answer. And one thing to note here is that this partially deactivated palladized charcoal is also known as Lindlar's catalyst. Okay, so remember this. Alright, now next question is from the chapter P block elements, and the question is the correct structure of tribromo octaoxide is. So tribromo, that means 3 bromine atoms are there, and octaoxide means 8 oxygen atoms are there. So 3 bromine and 8 oxygen atoms should be there, right? Now another important thing to note about tribromo octaoxide is that it is a neutral molecule. Now what does this mean? It means that it does not carry any charge. So no charge is there. And the most important thing is that all the oxygen atoms will be bonded with double bonds with bromine atoms. Okay, so all oxygen atoms bonded with double bonds with bromine atoms. Now keeping these things in mind, can we find out the correct answer? In the last one, we can see that all the oxygen atoms are bonded with double bonds with bromine atoms. Also, it does not carry any charge. So this will be the correct answer. Whereas in other options, you will see some single bonds are there and then some charges are also there. For example, in the third one, this is a single bond, this is a single bond, this is a single bond. Also, oxygen is carrying some charge. So this cannot be the correct answer. In other two options as well, there are some single bonds and oxygen is carrying negative charge. So these cannot be the correct answers. Only option D is the correct answer here. Now question number 3 is from the chapter electrochemistry, and the question is for a cell involving one electron, E0 cell is equal to 0.59 volt at 298 Kelvin. Then the equilibrium constant for the cell reaction is. Okay, so we have to find out the equilibrium constant, that is K equilibrium. Now it is given that only one electron is involved, that means the value of N is 1, E0 cell is 0.59 volt, and also it is mentioned that 2.303 RT by F is equal to 0.059. So we know that E cell is nothing but cell potential. and E naught cell is also cell potential but at standard state. Okay. And how do we find the cell potential? E cell is given as E naught cell minus 2.303 RT by NF log Q. Now we know that at equilibrium, what happens? The value of Q becomes equal to equilibrium constant and the total cell potential, that means E cell, becomes 0. Okay. So this full expression will become 0. So we can write that at equilibrium, E naught cell minus 2.303 RT by NF log K equilibrium, because now Q is equal to K equilibrium. So this total expression will become 0. Okay. Now let's put the values. E naught cell is given as 0.59. So 0.59 minus, it is also mentioned in the question that 2.303 RT by F is equal to 0.059. So 0.059 and the value of N is 1 log K equilibrium is equal to 0. So we can write that 0.059 log K equilibrium is equal to 0.59. Okay. So log K equilibrium will be equal to 0.59 divided by 0.059. So on dividing this, we'll get 10. Now we have to find out the value of K equilibrium. So it will be equal to log inverse, or we can say anti-log 10, right? So what is anti-log 10? It will be 10 to the power 10. So it can be written as 1 into 10 to the power 10. Both are same. So out of the given options, option B will be the correct answer. Question number 4 is from the chapter Alcohols, Phenols and Ethers. And the question is, the structure of intermediate A in the following reaction is. Okay. So in the given reaction, we can see that the reactant is an isopropyl benzene, that is also known as cumene. So cumene is isopropyl benzene. Now this cumene is reacting with oxygen present in the air to give us an intermediate A, which on hydrolysis gives two products. So one of the products is phenol and the other product is a ketone, that is acetone. Okay. So this phenol is the main product and acetone is a byproduct. Still it is produced in large amount. Okay. So it is an important method for the preparation of phenol from a hydrocarbon. Okay. So here what happens when cumene is oxidized in the presence of air, an intermediate known as cumene hydroperoxide is formed. Okay. So let's have a look at the structure. This is the benzene ring. So this will remain as it is. And here we have carbon. This side we have a methyl group. This side we have a methyl group. So out of 3 methyl groups, 2 methyl groups will remain here and 1 will be replaced by oxygen. Okay. So OH. So H was already there here. Okay. With carbon. So only oxygen has been added, replacing 1 methyl group. Okay. Now on hydrolyzing this, we'll get the phenol and acetone. So this is cumene hydroperoxide that is obtained as an intermediate. So out of the given options, the first one is the correct answer. Question number 5 is from the chapter P block elements, and the question is, the number of moles of hydrogen molecules required to produce 20 moles of ammonia through Haber's process is. Okay. So what is Haber's process? It is a method that is used for the production of ammonia gas. Okay. So we just need to remember the correct equation that is involved in this process. Okay. So in Haber's process, nitrogen gas reacts with 3 moles of hydrogen gas to give us 2 moles of ammonia gas. Okay. And the process is reversible. Now looking at this equation, we can say that for the production of 2 moles of ammonia, 2 moles of ammonia, what moles of hydrogen molecules are required? 3 moles of hydrogen are required. Okay. Therefore, for 1 mole of ammonia, what mole of hydrogen will be required? 3 by 2. Okay. And here, according to this question, we have to obtain 20 moles of ammonia. Okay. So 20 moles of ammonia should be produced. So for 20 moles of ammonia, 3 by 2 into 20 moles of hydrogen will be required, right? So what will we get here? 3 into 10, that means 30 moles of hydrogen molecules will be required. So option B will be the correct answer. Question number 6 is from the chapter Biomolecules, and the question is the non-essential amino acid among the following is, okay, options are leucine, alanine, lysine and valine. So the non-essential one is alanine, okay, others are essential amino acids. But what do we mean by essential and non-essential amino acids? We know that amino acids are categorized into two groups. First one is essential and the other one is non-essential. Okay. So what is the difference between them? As the name suggests, it is essential for us to consume some amino acids, and these are known as essential amino acids. Okay. Because these are not produced within our bodies. Not produced within our bodies. Therefore, they need to be consumed. Whereas non-essential amino acids are produced inside our body. Therefore, it is not required to consume these amino acids. Okay, so these need not be consumed. So out of the given options, alanine is the example of non-essential amino acid, and the structure of alanine is something like this: hydrogen, carbon, this is a amino group, this is carboxyl group, and it has one methyl group. Okay, so this is the structure of alanine. Other options are examples of essential amino acids. Question number 7 is from the chapter States of Matter, and the question is a gas at 350 Kelvin temperature and 15 bar pressure has molar volume 20% smaller than that for an ideal gas under the same conditions. Then the correct option about the gas and its compressibility factor Z is, okay. So first of all we should know that this compressibility factor Z is also known as gas deviation factor. Deviation factor. And what do you understand by gas deviation factor? See, this compressibility factor describes the deviation of a real gas from ideal gas behavior. Okay, so let's write it down here. It describes the deviation of a real gas from ideal gas behavior. And how do we find the compressibility factor? It is given as the ratio of actual volume of the gas, that means real volume, and the volume predicted by the ideal gas law at a given temperature and pressure. That means real volume by ideal volume. And the value of compressibility factor give us the nature of the gas molecules. Okay. For example, when this compressibility factor is less than 1, it means that the attractive forces are predominant. Okay. So attractive forces are predominant. And what does this mean? That the gas will be able to compress and liquefy easily. Okay. Compress and liquefy easily. On the other hand, If this value is more than 1, it means that the repulsive forces will be predominant. Okay, repulsive forces are predominant, and in this case what will happen, the gas will expand easily. Okay, it will not compress. So according to this question, the volume of the gas is 20% smaller than that for ideal gas. That means this real volume is smaller as compared to the volume of ideal gas. Okay, this means this whole value will be less than 1. So Z will be less than 1. That means attractive forces will be predominant and the gas will be able to liquefy easily. So which option will be the correct one? See, Z is less than 1. Attractive forces are dominant. That means option B is the correct answer. Question number 8 is from the chapter Redox Reactions, and the question is, which of the following reactions are disproportionation reaction? So what happens in disproportionation reaction? See, suppose we have a reactant and after the reaction we get two products A and B. Now the reactant as well as these products contain the same elements. Then what will happen? The element in the reactant side will have an intermediate oxidation state. So suppose the oxidation state is X here, then the oxidation state of that element in one of the products will be more than X, whereas the oxidation state in another product will be less than X. Okay. For example, look at the first one. Here we can see that the oxidation state of copper on the reactant side is +1. Okay. So this is +1. Now after the reaction we get +2 and 0. Okay, so the oxidation state of copper in one of the products is +2 and in other it is 0. So we can see that on the reactant side it is intermediate between +2 and 0. Okay, so this is the example of disproportionation reaction. Got it? Disproportionation reaction. Now in the second one we can see that the oxidation state of manganese on the reactant side is +6 and on the product side it is +7 here, and in manganese dioxide it is +4. Okay, so again +6 is the intermediate between +7 and +4. So this is also the example of disproportionation reaction. Now in the third one we can see that the oxidation state of manganese on the reactant side is +7. On the product side in this K2MnO4 the oxidation state is +6 and in manganese dioxide it is +4. So this time we can see that the reactant oxidation state is not intermediate. Okay, this side we don't have any oxidation state that is more than +7. So this will not be the example of disproportionation reaction. Okay, and in the last one we can see that the oxidation state of manganese on the reactant side is +7, then +2, and then on the product side it is +4. So this time the process is reversed. Okay, that means the intermediate oxidation state is on the product side. So this will also not be the proportionation reaction. So only A and B are the examples of disproportionation reaction. So option D will be the correct answer. A and B only. Now question number 9 is from the chapter P block elements, and the question is, which is the correct thermal stability order for H2E, where E is oxygen, sulfur, selenium, tellurium and polonium. That means E is some group 16 element. Okay, because all these elements belong to group 16. Now we know that the order of elements in group 16 is like this: oxygen, then sulfur, then selenium, then tellurium and then polonium. Okay. Also we know that on going down the group the size of the atoms increases. Okay. So suppose this is the size of oxygen, this is sulfur, this is selenium, this is tellurium and then this is polonium. So the size is increasing. Now H2E, that means hydrogen molecules will be bonded with these elements. Okay, so the size of hydrogen will remain same. Okay, so this is hydrogen, this is hydrogen, hydrogen. So as we can see that the bond length will keep on increasing as we move down the group, because the size of the group 16 elements will keep on increasing. Okay, so what will be the thermal stability? We know that stability is inversely proportional to the bond length. Okay, so here the bond length is increasing, therefore since bond length is increasing, therefore thermal stability will decrease. Okay, because this is inversely proportional to the bond length. So from oxygen to polonium, the thermal stability will decrease. So the correct sequence will be the second one. It is maximum for oxygen, then it will decrease for sulfur, then selenium, then tellurium, then polonium. Or we can say that from polonium to oxygen, it will increase. Okay, so option B will be the correct sequence. Question number 10 is from the chapter Structure of an Atom, and the question is 4d, 5p, 5f and 6p orbitals are arranged in the order of decreasing energy. Then the correct option is, okay. So we know that the energy of an orbital can be determined using n plus L rule, okay. So this n plus L value gives us the energy of orbital. So this is proportional. That means more the n plus L value, more will be the energy of the orbital. Okay. Now what is n here? N is the principal quantum number. Okay. Principal quantum number, whereas L is the azimuthal quantum number. Now we know that for s orbital the value is 0, for p orbital the value is 1, for d orbital the value is 2, and for f orbital the value is 3. Okay. Now we have 4 orbitals mentioned in the question: 4d, 5p, 5f and 6p, right? So what is the value of n? It is 4, and the value of L is D, we have 2. Okay, so 2. So 4 plus 2, that means N plus L value will be 6. For the second one, the value of N is 5, the value of P is 1. So the value of N plus L will be 6 again. Then 5 plus, for F we have 3. So 5 plus 3, that means 8. And for the last one, the value of N is 6 and the value of L is 1, because it is p orbital. So the value of N plus L will be 7. Now if we arrange them in decreasing order, we can write 8, then 7, then 6. Now we have 2 6 here. So when we have same value of N plus L, same N plus L value, then we'll focus on the value of N. Okay, the one in which the value of N will be more, that will be more stable. Okay, so if we arrange, 8 is the value of 5f orbital, so 5f, then 7 is 6p, then for 6 we have 2 orbitals, 4d and 5p. So in which of them n is greater? This one. Okay, 5p. So 5p, then 4d. Okay, so this is the correct sequence. That means out of the given options, the last one, option D, is the correct answer. Question number 11 is from the chapter Equilibrium, and the question is, which will make basic buffer? So what does basic buffer contain? It contains a weak base and its salt, right? And its salt. Now let's have a look at the given options. In the first one, we can see that the acid is acetic acid and the base is sodium hydroxide. So we know that sodium hydroxide is a strong base. So this cannot make a basic buffer, because for that we need a weak base, not a strong base. Okay. So this is not the correct answer. Similarly, in the third and the fourth one also, the base is sodium hydroxide, which is a strong base. So again, these cannot be the correct answer. The only possibility is that option B is the correct answer, because it has sodium hydroxide as the base, which is a weak base. Okay. Therefore, option B will be the correct answer here. But still, let's have a look at the reaction. So we have HCl plus ammonium hydroxide. and it will give us ammonium chloride plus water. Okay. Now we know that molarity is given as number of moles divided by volume in liter, right? So what will be the number of moles? It will be molarity into volume. Okay. So here for HCl it is given that the volume is 100 ml and molarity is 0.1 molar. So what will be the number of moles? It will be 100 into 0.1 and it will be in millimoles. Okay, so this will be 10 millimoles. Why millimoles? Because we know that volume is written in liter, but here it is milliliter, so the number of moles will also be in millimoles. Okay, similarly for ammonium hydroxide the volume is 200 and the molarity is 0.1, so 200 into 0.1, that means 20 millimoles, right? Now this is before reaction and the number of moles of ammonium chloride and water will be 0 before the reaction. Now what will happen after the reaction? After the reaction, the number of moles of HCl will be 0. No moles of HCl will be left. Okay. Number of moles of ammonium chloride will be 10 millimoles and also ammonium hydroxide will be 10 millimoles. That means 10 millimoles of HCl and ammonium hydroxide both have been consumed, okay, to give 10 millimoles of ammonium chloride. So what is left? 10 millimoles of ammonium hydroxide is left and 10 millimoles of ammonium chloride is left. That means weak base ammonium hydroxide and its salt ammonium chloride is left, okay. So weak base and its salt means a basic buffer. So this will be the correct answer. Question number 12 is from the chapter Classification of Elements and Periodicity in Properties. And the question is, for the second period elements, the correct increasing order of first ionization enthalpy is. Okay. Now, if we arrange the second period elements from left to right in a periodic table, what will be the correct arrangement? It will be lithium, then beryllium, boron, carbon, nitrogen, oxygen, fluorine and neon, right? And what will be the electronic configuration of these elements? For lithium, it will be 1s2, 2s1. For beryllium, 1s2, 2s2. And boron onwards, p orbitals will be involved. So it will be 1s2, 2s2, 2p1. For carbon, 2p2. Then 2p3, 2p4, 2p5 and 2p6. Right? And we know that as we move from left to right in a periodic table, the size of the elements goes on decreasing. Therefore, the ionization enthalpy goes on increasing. Okay. So, according to the general trend, the order should be like this: lithium, then beryllium, then boron, then carbon, nitrogen, oxygen, fluorine and neon. But there are some exceptions. As you can see, in case of beryllium, it has completely filled 2s orbital, okay, and in case of nitrogen it has half filled p orbital. Therefore these two will be more stable as expected, okay. So they will be having more ionization enthalpy as compared to the next element, okay. So beryllium will have higher ionization enthalpy as compared to boron and nitrogen will have higher ionization enthalpy as compared to oxygen, okay. So the positions will be interchanged like this. So the correct order will be lithium, then boron and then beryllium, okay, because beryllium is more stable than boron. Then carbon and then oxygen and then nitrogen because nitrogen is more stable than oxygen, and then fluorine and neon, okay. So which option will be the correct one? Option A. This shows the correct sequence. Question number 13 is from the chapter Chemical Bonding and Molecular Structure, and the question is, identify the incorrect statement related to PCl5 from the following. Okay, so we'll go through the statements, but before that let's draw the structure of PCl5 molecule. So this is the central atom, that is phosphorus. Now two chlorine atoms form axial bonds, that means bonds along the axis of the molecule, okay, whereas three other chlorine atoms form equatorial bonds, that means bonds along the equator of the molecule. Now the bond length of axial bonds is 240 picometer, whereas that of equatorial bond is slightly less than that, that means 200 2 picometer. Okay. Now let's come to the statements here. The first statement says that the two axial PCl bonds make an angle of 180 degree with each other. So we can see that these axial bonds are in a straight line, right, along the axis of the molecule. So this will form 180 degree angle. Okay. So this is a correct statement. Now we come to the second statement. It says that axial PCl bonds are longer than the equatorial PCl bonds. So here we have already seen that the bond length of axial bonds is 240 picometer, whereas that of equatorial is 202. So yes, axial bonds are longer than the equatorial bonds. So this is also a correct statement. Okay. Now we come to the third one. It says PCl5 molecule is non-reactive. Now this is not a correct statement because due to the longer axial bonds, these will break easily. Okay. So when they will break easily, then they will react easily. Okay. So let's write it down here. Due to longer and hence weaker axial bonds, PCl5 is a reactive molecule. Did you understand this? We know that bond length is inversely proportional to the bond strength, right? Therefore, when the bond length is more, the strength will be less, so it will break easily, right? So this is the incorrect option. Now what is the fourth one? It says three equatorial PCl bonds make an angle of 120 degree with each other. So this is also true, okay? These will form 120 degree angle with each other. So only incorrect option is option number C. Question number 14 is from the chapter Chemical Bonding and Molecular Structure. And the question is, which of the following diatomic molecular species has only pi bonds according to the molecular orbital theory? Options are nitrogen molecule, carbon molecule, beryllium molecule and oxygen molecule. So let's start with the first one, that is nitrogen molecule. What is the electronic configuration of nitrogen? It is 1s2, 2s2 and 2p3, right? Now we have to fill these electrons. So we know that the s orbitals are completely filled. So we'll consider the p orbital only while filling the electrons. So we have 2p3, that means 3 electrons this side and 3 electrons this side. Okay. Now we know that there are two types of molecular orbitals, bonding molecular orbitals and anti-bonding molecular orbitals. So lower ones are bonding molecular orbitals and the upper ones are anti-bonding molecular orbitals. Okay. Here this is pi 2px, this is pi 2py and this is sigma 2pz. Similarly, this is pi star 2px, this is pi star 2py and this is sigma star 2pz. Okay, star shows that these are anti-bonding molecular orbitals. Okay, so total number of electrons are 6, 3 this side and 3 this side. So we'll start filling from the lowest part. So 1, 2, then pairing will be done. So 3, 4, then 5, then 6. Okay, so what will be the bond order of nitrogen? It will be half the number of electrons in bonding molecular orbital minus number of electrons in anti-bonding molecular orbital. So this is half. And how many electrons in bonding? These total are bonding, right? So it's 6 electrons minus anti-bonding, these ones 0. So this will be 3. That means nitrogen has triple bonds, 3 bonds. And out of these triple bonds, one will be sigma bond and 2 will be pi bond. Why? Because one pair of electron is available in sigma molecular orbital and 2 pairs of electrons are available in pi orbitals. Okay. Therefore, 1 sigma and 2 pi. So this cannot be correct answer because we have to find out the one in which only pi bonds are available, no sigma bonds. Okay. So let's try for the carbon C2 molecule. What is the electronic configuration of carbon? This is 1s2, 2s2 and 2p2, right? Now we'll draw the similar diagram. We'll consider only this 2p2. Okay. So first we'll fill the electrons in these boxes. So 2p2 means 2 electrons this side and 2 electrons this side. Okay. And here we have bonding molecular orbitals. And on the upper part we have anti-bonding molecular orbital. Isn't it? This is pi 2px, this is pi 2py, and this is sigma 2pz. Similarly, this is pi star 2px, this is pi star 2py, and this is sigma star 2pz. So we'll start filling from the lower side. So total number of electrons are 4, 2 this side and 2 this side. So 1, 2, and then pairing 3, 4. Filled, all the electrons completed. So no electrons move to the sigma orbital. Okay. Here in nitrogen, one pair of electron was available in sigma, but here no electron is available. So we can say that it will not have any sigma bond. Okay. First we can find out the bond order. Similarly, half the number of electrons in bonding minus number of electrons in anti-bonding orbital. So half, how many in bonding? Total 4. How many in anti-bonding? 0. So half into 4 will be 2. That means it will have double bond. So carbon will have double bond, 2 bonds, out of which both the bonds will be pi bonds. Okay. So both pi and no sigma, because sigma orbital is totally empty. So this is the correct answer. Option B will be the correct answer. Okay. And for beryllium, it is quite clear that it cannot be the correct answer because its electronic configuration is 1s2, 2s2. So no p orbitals, that means no pi bond. Okay. Similarly, if we draw the same diagram for oxygen, we can find out that it also has sigma bonds. Okay. Only carbon will not have any sigma bond. So option B will be the correct answer. Now this question is again from chemical bonding and molecular structure, and the question is the number of sigma and pi bonds in pent 2-ene 4-ine is. Okay, so let's draw the structure of pent 2-ene 4-ine. Pent means 5 carbons, so 1, 2, 3, 4 and 5. Okay, 2-ene means we have a double bond at second carbon. So if this is carbon number 1, this is carbon number 2, then we'll have a double bond here. Then this is carbon number 3, this is 4, this is 5. So at fourth position we'll have triple bond. 4-ine means we will have triple bond here. Okay, now we'll have one hydrogen here, one hydrogen, one hydrogen, and then 3 hydrogens this side. Okay, now we know that all the single bonds will be sigma bonds and all the multiple bonds will also contain one sigma bond. Okay, so how many total number of bonds are there? 1, 2, 3, 4, then 5, 6, 7, 8, 9 and 10. Okay, so total number of sigma bonds will be 10. Okay, now next one is pi bond. So we know that in multiple bonds other than one sigma bond, all will be the pi bonds. Okay, so we have only two multiple bonds here, this one and this one. So here we have one sigma and one pi. Okay, so one pi bond here, and here we have one sigma and two pi, so two pi bonds here. So total number of pi bonds will be 3. Okay, so 3 pi bonds. So which will be the correct answer? Option number D, 10 sigma bonds and 3 pi bonds. So option D is the correct answer. Question number 16 is from the chapter Environmental Chemistry, and the question is, among the following, the one that is not a greenhouse gas is. Okay, options are methane, ozone, sulfur dioxide and nitrous oxide. So what is a greenhouse gas? It is a gas that absorbs the thermal energy into the Earth's atmosphere. Okay, so let's write down the definition. A greenhouse gas is a gas that absorbs and emits radiant energy within the thermal infrared range. Okay, the thermal infrared range, causing the greenhouse effect. So this effect leads to the heating of the environment. Okay, and what are the examples of greenhouse gases? It is water vapor, then carbon dioxide, then methane, then nitrous oxide and ozone. Okay, so these are the examples of greenhouse gases. So it's quite clear that out of the given options, sulfur dioxide is not the example of greenhouse gases. So option C will be the correct answer. Okay, whereas all the other three are greenhouse gases. Now question number 17 is from the chapter thermodynamics, and the question is, under isothermal condition, a gas at 300 Kelvin expands from 0.1 liter to 0.25 liter against a constant external pressure of 2 bar. Then the work done by the gas is, okay. So here initial volume is given as 0.1 liter and final volume is given as 0.25 liter, okay. Also, it is given that the gas expands against a constant external pressure. This is important because this shows that the process is an irreversible process. Okay, so irreversible process, and we have to find out the work done by the gas. So we know that the work done in case of irreversible process is given as minus P external into delta V. Okay, where this is the external pressure and delta V is the change in volume. So it can be written as minus P external final volume minus initial volume, right? Now let's put the values. Minus external pressure is given as 2 bar. So 2 bar, and final volume is 0.25 liter. Initial volume is 0.1 liter. So here we'll get minus 2 bar into 0.15 liter, right? So on multiplying this, we'll get minus 0.30 liter bar, or bar liter, both are same. Anyways, so it is given that 1 liter bar is equal to 100 joule. Here you can see in the question. So 1 liter bar equals to 100 joule. Therefore, if we have to convert this value, that means minus 0.30 liter bar, then it will be equal to minus 0.30 into 100 joule, right? So what will we get? We'll get minus 30 joule. So which will be the correct answer? Option D will be the correct answer, minus 30 joule. Question number 18 is from the chapter General Processes and Principles of Isolation of Elements. And the question is, which one is malachite from the following? Okay, so this is just a memory based question. We know that malachite is a copper carbonate hydroxide mineral. Okay, that means it is a basic copper carbonate mineral. It is copper carbonate hydroxide mineral, and it is bright green in color. Okay, bright green colored mineral. So option B will be the correct answer. This is the correct formula for malachite. Okay, copper carbonate and copper hydroxide. Question number 19 is from the chapter Solutions, and the question is, the mixture that forms maximum boiling azeotrope is. Okay, so what do you mean by maximum boiling azeotrope? These are the mixtures or solutions that show negative deviation from the Raoult's law. Okay, or we can say negative deviation from ideal gas behavior, right? Now we know that solutions consist of solute as well as solvent, right? Now suppose that solute is made up of type A molecules and solvents are made up of type B molecules. Then there will be some interaction within the solute molecules, that will be AA interaction. Also there will be interaction between solvent molecules, that means BB interaction. Now when these two are mixed together in a solution, there will be some interaction between A and B molecules, right? Now, if this interaction is a strong interaction, then what will happen? They will show negative deviation from Raoult's law. Okay. And negative deviation means it will form maximum boiling azeotrope. Okay. Now let's come to the given options. The first one is ethanol plus water. So we know that ethanol consists of hydrogen bonding and water also consists of hydrogen bonding. Okay. Now when they are mixed together, they will form weaker interactions. Okay. So on mixing together, ethanol and water form weaker interactions. So they will show positive deviation from Raoult's law, not negative deviation, okay? And they will form minimum boiling azeotrope. But we have to find a maximum boiling azeotrope. So this will not be the correct answer, okay? Now we come to the second one. It is acetone plus carbon disulfide. So acetone consists of carbon double bond oxygen, okay, and carbon disulfide, that means CS2. So we know that acetone is a polar molecule and carbon disulfide is a non-polar molecule, okay. Now when they are mixed together, what happens? The acetone loses its polarity because carbon disulfide gets in between two acetone molecules, okay. So again they will form weaker interactions, same as the first one, okay. So weaker interaction, that means which type of azeotrope? Minimum boiling azeotrope, okay? Minimum boiling azeotrope. Again, this will not be the correct answer. Now we come to the third one. It is heptane plus octane. So this is almost similar, okay? There is a difference of CH3 only, okay? Only one octane consists one more methyl group, okay? So this is more or less same as ideal gas. So it will show ideal gas behavior. It will neither show positive deviation nor show negative deviation. Okay. So this is also not the correct answer. Now the only left one is last one. So here we can see we have water and nitric acid. Okay. So this solution forms stronger interaction. So out of the given options, this is the only one which forms stronger interaction and shows negative deviation. Okay. Negative deviation. Therefore, it is maximum boiling azeotrope. So option D will be the correct answer. Question number 20 is from the chapter polymers, and the question is the biodegradable polymer is, options are nylon 2, nylon 6, nylon 6, Buna S and nylon 66. Okay. So what is biodegradable polymer? The polymer which can be broken down by decomposition, right? So broken down by microbial decomposition because it is done by the microorganisms, right? So microbial decomposition. Now we know that for decomposition it should be a natural polymer, right? So the first one, nylon 2, nylon 6 is a natural biodegradable polymer. Therefore option A will be the correct answer, okay? Whereas degradable, whereas all the other options are synthetic polymers. Now let's have a look at the structure of nylon 2, nylon 6. We know that the monomers are glycine and aminocaproic acid. So glycine is NH2, CH2 and COOH. Okay, this is glycine. That means it is an amino acid. Plus another monomer is N molecules of NH2, then 5CH2, then carboxyl group. Okay, this is aminocaproic acid, and when these two are combined it forms a polymer known as nylon 2, nylon 6. Okay, NHCH2, C double bond O, NH, then 5CH2, then again C double bond O. So this is nylon 2, nylon 6. Question number 21 is from the chapter Structure of Atom, and the question is, which of the following series of transitions in the spectrum of hydrogen atom fall in visible region? Okay, so we know that the wavelength range for visible region in the spectrum is 400 nanometer to 700 nanometer, right? And this is the wavelength range of Balmer series. Therefore option A will be the correct answer. Okay, it falls in the visible region. Now if we talk about other options, then Passion series and Bracket series both fall in the infrared region. Okay, infrared region, whereas the Lyman series, the last one, belong to the ultraviolet, that is UV region. Now question number 22 is from the chapter solutions, and the question is, for an ideal solution the correct option is. So the first one is delta V of mixing is non-zero at constant temperature and pressure. Delta V means volume change. Then option B is delta H of mixing is equal to 0. That means enthalpy change is 0 at constant temperature and pressure. Then third one is Gibbs energy change is 0 at constant temperature and pressure. And the last one is entropy change is 0 at constant temperature and pressure. Okay, so what is an ideal solution? We know that the solution which obeys Raoult's law. Okay, let's write it down here. Solution which obeys Raoult's law over the entire range of concentration are known as ideal solution, right? Now an ideal solution has two important properties. First of all, that delta H of mixing, that means enthalpy change of mixing, is 0. That means there is no change in enthalpy, or you can say that heat is neither absorbed nor released. Okay, neither absorbed nor released. Now if we talk about volume, then delta V of mixing also is 0. Okay, that means no change in volume. So the volume of the solution will be equal to the sum of volume of the components. Okay. Then other things are that entropy change is positive, whereas the Gibbs energy change is negative. Okay. So here we can see that Gibbs energy is given equal to 0. So this cannot be correct. Entropy change is given as 0. So this also cannot be correct. Volume is non-zero. This also cannot be correct because it is 0. Okay. And only the possible option is second one, that is enthalpy change is 0 at constant temperature and pressure. So yes, this is a correct one. So option B is the correct answer. Question number 23 is from the chapter S block elements, and the question is, which of the following is an amphoteric hydroxide? Okay, so what do you mean by amphoteric? It means it will react with acid as well as base. Okay, so react with an acid as well as a base. Okay, so here in the options we can see hydroxides of alkaline earth metals. First one is calcium hydroxide, then magnesium hydroxide, then beryllium hydroxide, and last one is strontium hydroxide. So out of the given options, option C, that is beryllium hydroxide, will be an amphoteric hydroxide. Okay, so let's see the reaction. Suppose beryllium hydroxide reacts with an acid HCl, okay, hydrochloric acid. Then it will give us beryllium chloride plus water. Whereas if it reacts with a base, suppose sodium hydroxide, then what will it give? It will give berylate ion. Okay, so what will be formed here? Sodium berylate. Okay, so we can see that it reacts with acid as well as base, therefore it is amphoteric in nature. Question number 24 is from the chapter Chemical Kinetics, and the question is, if the rate constant for a first order reaction is K, then the time required for the completion of 99% of the reaction is given by. Okay, so we know that for a first order reaction, the rate constant K is given as 2.303 by T log A0 by AT, where A0 is the initial concentration of the reactant and AT is the concentration left after time T. Okay. Now what will happen after 99% completion of the reaction? 99% of the reactant will be used up. Okay. So how much will be left? Only 1%. So after 99% completion of the reaction, 99% of reactant will be used up. So only 1% of the reactant will be left. Okay. So we can say that after time t, the rate constant K will be equal to 2.303 by T log 100 by 1. That means if the reactant, initial amount of reactant is 100, then after time T only 1% of 100 will be left, then only 1 will be left. Okay. So it will be 100 only. So it can be written as 2.303 by T log 10 to the power 2, that is log 100. Okay. So we can say that K is equal to 2.303 by T 2 log 10, and log 10 is equal to 1. So it will be 2.303 by T 2 into 2. Okay, because log 10 is 1. So on solving this, we'll get 4.606 by T. Now we have to find out the time required, that means the value of this T. So this T will be equal to 4.606 divided by the rate constant K. Okay. So which option will be the correct one? Option number B will be the correct answer. Question number 25 is from the chapter Equilibrium, and the question is conjugate base for Bronsted acids, water and hydrogen fluoride are. Okay, so we should know about the Bronsted-Lowry theory here. So this theory gives us the definition of Bronsted acid and Bronsted base. Okay, so let's see what are the definitions. According to this theory, Bronsted acid is that substance that donates a proton. Okay, so it donates a hydrogen ion, or you can say a proton, to form its conjugate base. To form its conjugate base. On the other hand, Bronsted base is that substance that accepts a proton. Okay, it accepts a hydrogen ion or a proton to form its conjugate acid. Now, here it is given that water and hydrogen fluorides are the Bronsted acids. Okay, so if we talk about water and it acts as a Bronsted acid, then what will it do? It will donate a proton. Okay, so one of the hydrogen will be donated. So what will be left? Only one hydrogen will be left and one oxygen will be left. So what will be formed? OH minus ion, because one positive charge has been removed. So OH minus. Similarly, if from hydrogen fluoride the only proton is removed, then what will be left? Only fluoride ion will be left. Okay. So the Bronsted bases for these acids will be OH minus and F minus, that is fluoride ion respectively. Okay. So option B will be the correct answer. Question number 26 is from the chapter amines, and the question is the major product of the following reaction is. Okay, so we can see that on the reactant side we have a phthalic acid and an ammonia. Okay, so let's draw the structures again. This is our phthalic acid, that means two carboxyl groups at the adjacent carbons of the benzene ring, and this is reacting with ammonia. So what will be formed? The first intermediate will be ammonium phthalate. Okay. So this is our benzene ring. Here we have COO minus NH4 plus. And here also COO minus NH4 plus. So this is ammonium phthalate. Okay. Now, when it is heated, two molecules of water will be removed. Okay, so 2H2O will be removed. That means 4 hydrogens and 2 oxygens. So 2 hydrogen and 1 oxygen from here and 2 hydrogen and 1 oxygen from here. Okay, so what will be left? Here we have this structure. This is the benzene ring, and here CONH2 will be left, and here also CONH2 will be left. Okay. Now in the third and the last step, it is heated strongly. Okay, so on strong heating, what will be removed? This time one ammonia molecule will be removed. So here we have the benzene ring. Here we have C double bond O, C double bond O, and only one nitrogen and one hydrogen will be left. Okay, so these one nitrogen and one hydrogen will be common. So this is our phthalimide, and this will be the final product. Okay, so out of the given options, the correct one will be the first one. Okay, phthalimide. Question number 27 is from the chapter Alcohols, Phenols and Ethers, and the question is the compound that is most difficult to protonate is. That means it is difficult to add a proton to it. Okay. In the option 1 we can see that we have a methyl group on one side of oxygen and hydrogen on the other side. In option B we have methyl groups on both the sides. In option C we have a phenol on one side and hydrogen on the other side, and in the last one we have two hydrogens on both the sides. Okay. So we can see that option C is the only one where phenol is involved. What is phenol? This is benzene ring and this is OH. So this is phenol. Now we know that oxygen has lone pair of electrons. So these lone pair of electrons will be delocalized over the benzene ring and it will show resonance effect. Okay. Now due to this, the phenol will acquire a partial negative charge which will give rise to partial positive charge on the oxygen atom. Got it? Now since this is already positive, it will not attract a positive hydrogen ion or a positive proton. Okay? Therefore protonation will be difficult here. Now let's write it down here. Due to involvement of lone pair of electrons in resonance in phenol, what will happen? It will have positive charge. What will have positive charge? Oxygen. Okay, here we are talking about oxygen. Oxygen will have positive charge, partial positive charge. Therefore, the incoming proton will not be able to attack. Okay, so which is the correct answer? Option C is the correct answer. Question number 28 is from the chapter Chemical Kinetics, and the question is for the chemical reaction that is shown here. The correct option is, okay. So in all the options we can see that the rate of disappearance of the reactant and the rate of formation of product is compared, right? So we know that the rate of a reaction can be expressed in terms of rate of disappearance of any of the reactant or in terms of rate of formation of any of the product, okay. So rate is equal to rate of disappearance of any reactant, or it can also be equal to the rate of formation of any of the products. Okay, that means rate will be equal to minus dN2 by dt, minus sign because the reactant, the amount of reactant will be reducing. Okay, so minus sign, so minus dN2 by dt, and rate will also be equal to minus 1 by 3 dH2 by dt, because we can see that 3 moles of hydrogens are participating in the reaction. So this will be written like this, 1 by 3. Okay. Similarly, the rate will also be equal to the rate of formation of ammonia. So it will be plus 1 by 2 dNH3 by dt. Okay. This time plus sign because the amount is not reducing, it is increasing. So we can say that minus dN2 by dt will be equal to plus half dNH3 by dt. So which option will be the correct one? Option number B. Okay. This shows the correct expression. So option B is the correct answer. In the first one, we can see it is given 2, but it will be 1 by 2. Okay. So this is not correct. In the third one, we can see minus 3H2 by dH2 by dt is written. It will be minus 1 by 3. Okay. And here it will be 1 by 2. So this is also not correct. And here we can see that minus sign is given with ammonia. So ammonia is being formed, so it will be plus sign, right? So this is also not correct. Only correct one is option number B. Question number 29 is from the chapter thermodynamics, and the question is, in which case change in entropy is negative? Options are expansion of a gas at constant temperature, then sublimation of solid to gas, then conversion of gaseous hydrogen atoms to gaseous hydrogen molecule, and the last one is evaporation of water. Okay. So what does entropy change indicate? Entropy change, that is delta S, indicates the randomness of particles, right? That means if we have positive delta S, it means that there will be more randomness. So the particles will be free to move around. Whereas in case of negative delta S, there will be less randomness. So particles will not be able to move freely, right? Now, if we look at the given options, first one says expansion of a gas at constant temperature. So suppose we have a gas in this volume. Now if it expands, the same gas will be available in a larger volume. So there will be more space between the particles. So obviously the randomness will increase. The particles will be able to move freely, right? So increase in randomness will lead to positive entropy change, that means positive delta S. So this is not negative. We have to find out the negative, right? Now, second one is sublimation of solid to gas. So here we just need to remember one concept, that whenever solid is converted to liquid, or liquid is converted to gas, or you can say when solid is converted to gas, what happens? There will be weaker interactions, okay, as compared to the initial interaction. Got it? So this will lead to more randomness of particles. Again, there will be positive delta S value, that means positive entropy. Okay. So here you can see sublimation means what? Conversion of solid to gas. So obviously it will lead to positive delta S. So this is also not negative, right? Now again, for negative delta S, see, suppose if gas is converted to liquid or liquid is converted to solid, that is one condition when there will be negative delta S. Okay. Another condition for negative delta S is what? Decrease in the number of particles. Okay. So this is one condition, and the other condition is what? Weaker interactions among the particles. So in the third one, we can see that gaseous hydrogen atoms are being converted into gaseous hydrogen molecules. So here you can see we have 2 moles of hydrogen, and on the product side we have only 1 mole of hydrogen. So it is clear that the number of particle is decreasing. Okay, so it will lead to negative delta S value. Okay, so this is the correct answer. Now if we talk about the last option, it is evaporation. So evaporation is what? Liquid to gas. So it is quite clear that there will be more randomness when a liquid is converted to gas. So that will lead to again positive entropy change. So only condition when the entropy change is negative is the third one. Therefore option C will be the correct answer. Question number 30 is from the chapter amines, and the question is the correct order of the basic strength of methyl substituted amines in aqueous solution is. Okay, so we have to compare the basic strength of 1 degree, 2 degree and 3 degree amines. Now we know that in 1 degree amine only one methyl group is attached to nitrogen atom. So one methyl group and 2 hydrogen atoms. In 2 degree amines 2 methyl groups will be attached and 1 hydrogen atom will be there, and in 3 degree amines 3 methyl groups will be there. Now we know that methyl groups exhibit electron donating inductive effect. Okay, donating inductive effect. So in the first case only one methyl group will be donating electron towards nitrogen. In second case 2 methyl groups will be donating electron, and in the last one 3 methyl groups will be donating electron. That means the electron density will increase in this manner, 1 degree to 2 degree and then 3 degree. Okay, so the basic strength should also increase in the same manner. Okay, so this is the general trend. That means for gaseous phase. Okay, So this is for gas, because in gas only this effect will be applicable. But in case of aqueous solution that is mentioned in question, there are other effects that will be applicable. For example, solvation effect and steric hindrance. So these effects are also applicable in case of aqueous solution. Okay. So in aqueous solution. So the combined effect of these three, that means inductive effect, solvation effect and steric hindrance, will result in some change in this trend. So the resulting trend will be like this for amines. It will be maximum for 2 degree, then 1 degree and then 3 degree. Okay. So this will be the order of basic strength and you will have to remember this. Okay. Therefore, which option will be correct? 2 degree, that means 2 methyl groups. So this last one, then 1 degree, that means 1 methyl group, and then 3 degree, that means 3 methyl groups. So option D will be the correct answer. Question number 31 is from the chapter electrochemistry, and the question is for the cell reaction that is shown here. E naught cell is equal to 0.24 volt at 298 Kelvin. The standard Gibbs energy of the cell reaction is, okay. So we have to find out the value of delta G naught, and the value of Faraday constant is given as 96500 coulomb per mole. Okay. So this is a direct formula based question. We know that delta G naught of the cell is given as minus NF into E naught cell, where N is the number of electrons transferred, F is the Faraday constant and E is the standard potential of the cell. Okay, so this is standard potential. Now if you look at the reaction, you can see that the number of electrons transferred is 2. Okay, so 2 electrons are transferred, that means the value of N will be 2. So minus 2 into F is the Faraday constant and it is given as 96500. So 96500 and E naught cell is also given, it is 0.24 volt. Okay, 0.24. Now on multiplying these we'll get minus 46320 and the unit will be joule per mole. Now here in all the options you can see kilojoule is mentioned, kilojoule per mole is mentioned. So we'll divide it by 1000 to get the value in kilojoule per mole. So this divided by 1000. So we'll get minus 46.32 kilojoule. This is kilojoule per mole. So option D will be the correct answer. Question number 32 is from the chapter coordination compound, and the question is what is the correct electronic configuration of the central atom in potassium ferrocyanide based on crystal field theory. Okay, so we have K4FeCN6. Now let's find out the oxidation state of iron first. We'll assume that it is X. We know that the oxidation state of potassium is +1. So we have 4 potassium, that means +4. Also we know that the oxidation state of cyanide is -1. So for 6 cyanide it will be -6. Now on adding these we'll get 0. That means X minus 2 is 0. So the value of X is +2. Okay. That means we have Fe2 plus ion in this compound. Okay. Now what is the electronic configuration of iron? It is 4s2 3d6. Okay, so for Fe2 plus these 2 electrons will be removed, that means only 3d6 will be left. So this is the electronic configuration of iron in this compound. Okay, but we have to use the crystal field theory. So we know that this is an octahedral compound, right? So first we'll draw the orbitals, d orbitals. So 1 2 3 4 5. This is d orbital and we have 6 electrons, that means 1 2 3 4 5 and 6. Okay, now in case of octahedral compounds, 2 orbitals energy will increase and the energy of 3 orbitals will decrease. Okay, so these are 2 high energy orbitals and these are 3 low energy orbitals. Okay, the higher one is called Eg and the lower one is called T2G, right? Also we know that for strong field ligand, since here we have cyanide and cyanide is a strong field ligand. Okay, strong field ligand. So for such ligand, pairing takes place. Okay. So we have 6 electrons. So first these 6 electrons will be paired up in this lower energy orbitals, and then it will move to the higher energy orbital. Okay. So we have 6 electrons. So 1, 2, 3, 4, 5, 6. Okay. Now no more electron is left to go in the higher energy orbital. All the electrons are paired up in T2g orbital only. Okay. So what will be the electronic configuration? It will be T2g6 because 6 electrons are in T2g orbital, and Eg0 because no electron has moved to Eg level. Okay. So the correct option will be T2g6 and Eg0. That means option number A will be the correct answer. Question number 33 is from the solid states, and the question is, a compound is formed by cation C and anion A. The anions form hexagonal close packed lattice, that means HCP lattice, and the cations occupy 75% of the octahedral voids. Then the formula of the compound is, okay. So it is given that the anions are in HCP. Therefore, the number of anions will be 6. Right, and it is given that the number of cations is 75% of the octahedral void. That means number of cations will be 75% of 6. So it will be 75 by 100 into 6. So 25 into 3 is 75, 25 into 4 is 100. So 3 by 4 into 6, that means 18 by 4. So it can be simplified as 9 by 2. Okay. So if we write the formula of the compound will be, number of cations will be 9 by 2 and number of anions will be 6, right? Because number of cation is 9 by 2 and this is 6. Now we can simplify it. If we multiply the number of cations and anions both by 2, then we'll get C9 and A12. Okay. Also we can simplify it. 3 into 3 is 9, 3 into 4 is 12. So C3A4. Okay. So this will be the simplified formula of the compound. That means option number B will be the correct answer. Question number 34 is from the chapter hydrogen, and the question is, the method used to remove temporary hardness of water is, options are Clark's method, ion exchange method, synthetic resins method, and Kalgan's method. So the correct option will be option number A, that is Kalgan's method, and all the other three options are for the removal of permanent hardness of water. Permanent hardness. Now, what is the reason behind the temporary hardness of water? It is due to the presence of calcium or magnesium carbonates in water. Okay, so these cause temporary hardness. Now, what is done in Clark's method? Calculated amount of lime is added to hard water, which precipitates out the calcium or magnesium carbonate. Okay, so let's write down the reaction. First, in case of calcium carbonate, so this is calcium hydrogen carbonate. Now, what will be done? Slaked lime will be added. That means calcium hydroxide will be added to it. This is slaked lime. Now it will precipitate out the calcium carbonate and pure water will be formed. Now in case of magnesium carbonate, same process will be done. So this is magnesium bicarbonate. It will also react with slaked lime, that means calcium hydroxide. So this time, in addition to calcium carbonate will form here also. So calcium carbonate, other than this, magnesium hydroxide will also be precipitated out. So MgOH2, both will be precipitated out, plus obviously water will be formed. Now these precipitates can easily be filtered out. Okay, so this is the Clark's method. Question number 35 is from the chapter D and F block elements, and the question is, the manganate and permanganate ions are tetrahedral due to, options are, there is no pi bonding, then the pi bonding involves overlap of p orbitals of oxygen with p orbitals of manganese. Okay, so both are p orbitals. In the third one, The pi bonding involves overlap of d orbitals of oxygen with d orbitals of manganese. So here both are d orbitals. And in the last one, it is given that the pi bonding involves overlap of p orbitals of oxygen with d orbitals of manganese. So here one is p and the other one is d orbital. Okay. So let's draw the structure to see if there are any pi bonding or not. So first I'll draw the structure of manganate. So this is manganese. This is double bond oxygen, double bond oxygen. This is singly bonded oxygen and one more singly bonded oxygen. Okay. So this is MnO4 2 minus, that means manganate ion. Okay. Now the second one is permanganate. So manganese, double bond oxygen, double bond oxygen, double bond oxygen and one singly bonded oxygen. This is MnO4 minus, that means permanganate ion. Now here we can see that both contain pi bonds. So first option cannot be correct. Okay. Now we know that the electronic configuration of oxygen is 1s2, 2s2, 2p4. Okay. So is there any d orbital here? No. Only p orbital. Means still p orbital. So this cannot be the correct answer. The third one, here it is given that d orbitals of oxygens are involved. So if oxygen does not have any d orbital, how can it be involved? So this is also not true. Okay. Now we have only two options left, option number B and option number D. So we know that the electronic configuration of manganese is that of argon and then 3d5 4s2. So manganese contain d orbitals, that means d orbitals of manganese will be involved and p orbital of oxygen will be involved. That means option D will be the correct answer. Okay. Question number 36 is from the chapter Haloalkanes and Haloarenes, and the question is, among the following the reaction that proceeds through an electrophilic substitution is. Okay. So what happens in case of electrophilic substitution? An electrophile is generated. So the generation of an electrophile is the most important step here. After that, this electrophile will carry out the reaction. So let's try to find out the correct answer. First we'll eliminate the wrong ones. Okay. So in the second one we can see this chlorine molecule is reacting with UV light. That means radiation from the sun. So when this happens, chlorine radical will be generated. Okay. So generation of chlorine radical will take place. So which mechanism will follow? Free radical chain mechanism. Okay. So the reaction will proceed via free radical chain mechanism, not the electrophilic substitution. So this is not the correct answer. Now we come to the third one. Here we can see that this OH is being replaced by chlorine. And where will this chlorine come from? It will come from this HCl. So first this HCl will break into hydrogen ion plus chloride ion, and this chloride ion has to be added here. But this is negatively charged and we know that electrophiles are positively charged. Okay, so this is a nucleophile, not an electrophile. Therefore, which type of reaction will take place? Nucleophilic substitution reaction will take place, not the electrophilic substitution reaction. So this is nucleophilic substitution reaction. That means this is also not correct. Now we come to the last one. This is similar to the third one. Here also we can see that this nitrogen is being removed from here and chloride is being added. Okay. And where will that chloride come from? This one. Okay. So this will break into copper ion and chloride ion. Again the chloride is negatively charged. So this is also the example of nucleophilic substitution, not the electrophilic substitution reaction. So this is also not correct. So the only option left is the first one. So this is the correct answer. Now here let's see what happens. We have aluminium chloride and we know that aluminium chloride is an electron deficient molecule. Therefore it will act as a Lewis acid. Okay, Lewis acid, and it will attract the chlorine molecule because chlorine has high electron density and aluminium chloride lacks electron. Okay, So what will happen? This bond will break and one of the chlorine will be added to aluminum chloride. Okay. So what will be formed? AlCl4 minus plus Cl plus. Okay. So here we can see that this time chlorine is positively charged. Therefore, this is an electrophile. Okay. So now the electrophile has been generated. Now this electrophile will attack the benzene ring and form this halobenzene, that means chlorobenzene in particular. Okay, so option A will be the correct answer. Question number 37 is from the P block elements, and here we have to match the xenon compounds mentioned in column 1 with their structures mentioned in column 2. Okay, so let's start with the first one. It is xenon tetrafluoride. That means 4 fluorine atoms are there. Now how many electrons are available for bonding in xenon? Total 8 electrons. So out of these 8 electrons, 4 are involved in bonding with 4 fluorine atoms. So how many electrons left? 4 left. So these remaining 4 electrons will be available as 2 lone pairs. Okay. So this is the structure and it is square planar structure. That means the correct match for A will be number 2. Now we come to the second one. It is xenon hexafluoride. That means 6 fluorine atoms are there. Again the xenon has 8 electrons for bonding. Out of these 6 will be involved in bonding with 6 fluorine atoms. Okay. So 1, 2, 3, 4, 5 and 6. Okay. So there are 6 fluorine atoms bonded to the xenon. So out of 8 electrons, 6 are already utilized. So how many electrons left? 2 electrons left. So these remaining 2 will be available as one lone pair of electron. Okay. Now if there was no lone pair of electron, then this would be the octahedral. But due to the presence of lone pair of electron, it will be distorted octahedral. Okay. Distorted octahedral. That means the correct match for B will be number 3. Now we come to the third one. It is xenon oxytetrafluoride. So we have xenon. Now 4 fluorine atoms are there. So 1, 2, 3 and 4. Now out of 8 electrons, 4 are utilized. How many left? 4 electrons left. Then we have one oxygen atom also. So again 2 electrons involved in oxygen, bonding with oxygen. So how many left? 2 electrons left now. Again these 2 remaining will be available as one lone pair of electron. Okay. So what kind of shape is this? This is square pyramidal. Okay. Square pyramidal. That means the correct match for C will be number 4. Now the last one is xenon trioxide. So this is our xenon. Now 3 oxygens are there. So double bond oxygen, double bond oxygen, double bond oxygen. So 2 electrons, 2 electrons, 2 electrons. So 6 electrons have been utilized. How many left? Only 2 electrons left. So these will be available as lone pair of electron. Now what kind of structure is this? This is pyramidal. So the correct match for D will be number 1. Okay. So out of the given options, which one will be correct? The first one is the correct match. So option A is the correct answer. Question number 38 is again from the P block elements, and the question is which of the following is incorrect statement. Okay, so the first one is silicon tetrachloride is easily hydrolyzed. So this is a correct statement, and what is the reason? Reason is the presence of vacant d orbital in silicon. Okay, so let's write it down here. Due to the presence of vacant d orbital in silicon, this compound, that means silicon tetrachloride, will accept a lone pair of electrons. Lone pair of electrons donated by water molecule, right? Water molecule. And therefore, it will undergo hydrolysis. And it undergoes hydrolysis. Therefore, this statement is correct. Now we come to the second one. It says germanium tetrahalide is more stable than germanium dihalide. Okay, and here X represents the halogens fluorine, chlorine, bromine, or iodine. Okay, so we know that for the upper member of the carbon family, member of carbon family, what happens? +4 oxidation state is more stable than +2 oxidation state, right? So here we can see that in germanium tetrahalide the oxidation state is +4, and in germanium dihalide the oxidation state is +2. So which will be more stable? +4 oxidation state. That means germanium tetrahalide will be more stable. Okay. Therefore, this statement is also correct. Now we come to the third one. It says tin tetrafluoride is ionic in nature. Okay. So we know that tin is a metal. Tin is a metal. That means it is electropositive in nature, right? Whereas fluorine atom is highly electronegative. Okay, so this is a non-metal and this is highly electronegative. So obviously there will be polarity here, so this will lead to the formation of ionic compound. Okay, so this will be ionic in nature. Also we can say that tin metal has a large size and fluorine is of very small size. Okay, so according to the Fajan's rule, which says that in a compound where the size of the cation is large and the size of the anion is very small, then that will be ionic in nature. Okay, so the nature will be ionic. So this is also a correct statement. And the last statement says lead tetrafluoride is covalent in nature. But here also lead is a metal that is highly electropositive and is of large size, and fluorine is highly electronegative and it is of very small size. So due to the same reason it will also be ionic in nature. So this is not a correct statement because it will be ionic in nature similar to the tin tetrafluoride. Okay. So the incorrect statement will be option D. Question number 39 is from the chapter Hydrocarbons, and the question is an alkene A on reaction with ozone and zinc water gives propanone and ethanol in equimolar ratio. Addition of HCl to alkene A gives B as the major product. Then the structure of the product B is. Okay. So we have an alkene A. Suppose this is the alkene. Now according to the question it reacts with ozone and zinc water. That means it will undergo reductive ozonolysis. Okay. So what is formed here? Propanone and ethanol. So let's write down the structure. Propanone means CH3, C double bond O and CH3. Okay. So this is propanone. And the other product is ethanol. That means CH3, C double bond O and H. Okay. This is ethanol. Now before the ozonolysis, these two oxygens were not there. So let's remove these two oxygens to find out the reactant alkene. So what is left this side? CH3, CH3 is left. And on the right side, CH3 and H is left. Now these two carbons were joined by double bond. So this is the reactant alkene A. Okay. Now according to the question, when this alkene A reacts with HCl, it will give a product B. So let's see what is formed. This hydrogen chloride will be added to the alkene in such a way that hydrogen will get added to that carbon of the double bond which has more number of hydrogen. So it will be added to this carbon. Okay. Whereas chlorine will get added to the other carbon. So this carbon. So let's see what is formed here. CH3, then CH3, and to this carbon chlorine is also added. And here one hydrogen is already there and one more hydrogen will be added and CH3. Now if we reverse this, that means bring the right one on the left side, then what we can write? We can write like this. This is the carbon number 1, so we can write it on the left side like this, CH3. And this is carbon number 2, so we can write next CH2. then C, and we can write CH3 here, chlorine here, and then CH3, because options are given like this. Okay, so which option is the correct one? Here we can see number B has a similar structure, but here this hydrogen is wrong. Okay, this will not be there because the carbon containing chlorine will not have any hydrogen. Okay, so option B resembles this structure, so this is the correct answer. Question number 40 is from the chapter Surface Chemistry, and the question is, which mixture of the solutions will lead to the formation of negatively charged colloidal silver iodide salt? Okay, so what is the reason for negative charge on the colloid? The reason is adsorption of common ion from dispersion medium. Okay, so let's write it down here. Colloidal charge is due to the adsorption of common ion from the dispersion medium, right? Now let's write down the reaction here. We have silver nitrate AgNO3 plus potassium iodide, and what is formed after the reaction? Silver iodide and potassium nitrate. Okay, see, silver nitrate is the dispersed phase, potassium iodide is the dispersion medium, and silver iodide is the negatively charged salt, because it is given in the question. Okay, so this is the salt, charged salt. So iodide is the negative charge here. Okay, iodide is the reason for negative charge. So this has come from potassium iodide, therefore this is dispersion medium. Okay, now for more negative charge, this potassium iodide should be in excess. That means in comparison to silver nitrate, the amount of potassium iodide should be more. Okay, so the amount will be measured in number of millimoles. So let's compare one by one. In the first one, we can see we have 50 ml of 1 molar silver nitrate. So what is the millimoles of silver nitrate here? We know that number of moles is equal to molar concentration into volume. Okay, so 50 into 1 will be 50 millimole. Okay, and what is the number of millimoles of potassium iodide? It is 50 into 2. Okay, so this is 100 millimole. So we can see that the amount of potassium iodide is more than the silver nitrate. Okay, so this can be correct answer, but let's consider other options as well. In second one, we have silver nitrate is 2 into 50, that means 100 millimole, and potassium iodide is 1.5 into 50. Okay, 5 into 5 is 25, so it is 75 millimole. So here we can see that the amount of potassium iodide is less as compared to the silver nitrate. So this cannot be the correct answer, because potassium iodide should be in excess, right? It should be more. So this is not the correct answer. Now the third one is 50 ml of 0.1. So here both are 0.1, right? Volume is same, 50 ml, 50 ml. This is 0.1, this is 0.1. So this is same. The number of millimoles will be same. So this will also not be the correct answer. In the last one, this is 50 ml of 1 molar and this is 50 ml of 1.5. So here also potassium iodide will be more, but it will be less as compared to the first case. Okay, here we have 2, here we have only 1.5. So obviously the more negative charge will be in case of the first one. Okay, so option A will be the correct answer. Question number 41 is from the P block elements, and here we have to match the processes with the products that are obtained from these processes. Okay, so the first one is pure nitrogen. Now what is the process to get pure nitrogen? It is the thermal decomposition of sodium or barium azide. So the correct match for A will be number 4. Okay, let's see the reaction. So suppose the thermal decomposition of sodium azide is carried out, then we have sodium azide. Now the required temperature will be 573 Kelvin. And what will we get here? Sodium plus pure nitrogen. Okay. Similarly for barium azide, BaN3(2), it will be heated and we'll get barium plus pure nitrogen. Okay. So you understood how this sodium or barium azide gives us nitrogen. So now let's move to the second one. It is Haber process. So it's very common. Let's write down the reaction here. Nitrogen reacts with hydrogen to give ammonia. Okay. So this is the Haber process. That means Haber process is related to ammonia. So the correct match will be number 3. Now the third one is contact process. It is quite complicated. It is carried out in various steps. For example, sulfur dioxide reacts with oxygen to give sulfur trioxide first. Okay, sulfur trioxide, and the catalyst used is vanadium oxide, vanadium pentoxide. Okay, so this is the first step, and then this sulfur trioxide reacts with concentrated sulfuric acid. Okay, actually this is absorbed in the concentrated sulfuric acid to give us oleum. So this sulfur trioxide is absorbed in concentrated sulfuric acid to give us H2S2O7, that is oleum. Okay, then at last the oleum is diluted to give us the sulfuric acid of desired concentration. Okay, so this contact process is related to the production of sulfuric acid. That means the correct match for C will be number 2. Okay, this is number 2. Now we have the last one, that is Deacon's process. So let's write down the reaction here. HCl, that is hydrochloric acid, will react with atmospheric oxygen in the presence of CuCl2, that means copper chloride, to give us chlorine molecules plus water molecules. Okay, so this Deacon's process is related to chlorine. So the correct match for D will be number 1. Okay, so which will be the correct one? A4, that means this third one. So option C will be the correct answer. Question number 42 is from the chapter S block elements, and the question is, enzymes that utilize ATP in phosphate transfer require an alkaline earth metal as the cofactor. Then what is that metal M? Okay, options are magnesium, calcium, strontium and beryllium. So we know that the enzymes that utilize ATP in phosphate transfer require magnesium as the cofactor. So this is just a memory based question. You have to remember this. So option A will be the correct answer. Question number 43 is from the chapter Chemistry in Everyday Life, and the question is, among the following the narrow spectrum antibiotic is. Okay, so what is antibiotic? It is the medicine that is used to treat bacterial infections, right? So this is used for bacterial infections. Now these are broadly classified into two groups. First one is narrow spectrum and the other one is broad spectrum antibiotic. Okay, broad spectrum. What do you mean by narrow spectrum antibiotic? These are the antibiotics which target a very few types of bacteria. Okay, so target a small group, or you can say few types of bacteria. Whereas if we talk about the broad spectrum antibiotics, then these target a large variety of bacteria. That means the narrow spectrum are very specific. Okay, so out of the given examples, only penicillin G is the example of narrow spectrum, whereas all the other three are examples of broad spectrum. Okay, so here it is asked about the narrow spectrum, therefore option D will be the correct answer. Question number 44 is from the P block elements, and the question is, which of the following species is not stable? So these are the species, and what is the reason for the formation of such species? The reason is the presence of d orbital in these elements. Okay, so the presence of d orbital in silicon, germanium and tin. Now out of the given four options, one is not stable. That means one is not known or not formed. So what is that? This is the third one, silicon hexachloride. and the reason is the large size of chloride ions which cannot be accommodated around the silicon ion. Okay, so let's write it down here. 6 large chloride ions cannot be accommodated around silicon ion. And what is the oxidation state? +4. So silicon 4 plus ion due to limitation of its size. Okay. And then there is one more reason. Another reason is the weaker interaction. Okay. So this is one reason, and the another is interaction between the lone pair of chloride ion and silicon ion are very weak. Okay. Lone pair of chloride ion and silicon ion is not strong. So due to these two reasons, this compound or this species is not formed. And now the last question is from the chapter equilibrium, and the question is pH of a saturated solution of calcium hydroxide is 9, then the solubility product, that is Ksp of calcium hydroxide, is. Okay, so let's assume that the calcium hydroxide has solubility S. Now let's write down the reaction here. We have calcium hydroxide, and when it gets broken, then the resulting ions will be calcium ion Ca2 plus and 2OH minus ions, right? Both in the aqueous state. Now we know that the solubility of calcium hydroxide is S. Then what will be the solubility of calcium ion after the reaction? It will also be S. And that of OH minus ions will be 2S, because 2 moles of OH minus ions are there. So what will be the Ksp? It is the product of ionic concentrations of these two. That means the ionic concentration of calcium ion into the ionic concentration of OH minus ion raised to the power 2. So the ionic concentration of Ca2 plus will be S, and that of OH minus will be 2S. And here we have power 2, that means square. So here we'll get 4S cube. So this is the Ksp. Now suppose this is equation 1. Now let's come back to the question. It is given that pH of saturated solution is 9, and we know that the sum of pH and pOH is 14. pH is given as 9. So can we find out the value of pOH? Simple. It will be equal to 14 minus 9, that is 5. So pOH is 5, then what will be the concentration of OH minus ion? It will be 10 to the power minus 5. Okay. And we know that the concentration of OH minus ion is 2S from this reaction. So that means 2S is equal to 10 to the power minus 5. So what will be the value of S? It will be equal to 10 to the power minus 5 divided by 2. Okay. Another important thing to note here. So we'll assume that this is equation 2. So now we can find out the value of Ksp, right? We can put the value of S in this. That means we can put the value of 2 in 1. Okay. So Ksp is equal to 4S cube. That means 4 into cube of 10 to the power minus 5 by 2. Okay. So on solving this, we'll get 0.5 into 10 to the power minus 15. Okay. So this is the Ksp. So which will be the correct answer? Option number D will be the correct answer. 0.5 into 10 to the power minus 15. So here we complete all the chemistry questions from NEET paper 2019. We'll get back with another session. Till then, keep learning, keep scoring high. For any doubt related to papers, join our Telegram channel. Link is given in description. Also, do subscribe our YouTube channel for more such informative videos. Thank you. Hey champs of Examsnet, welcome to the question series of Examsnet. I hope this series of detailed explanation is helping you a lot. So today we are going to deal with physics questions from NEET paper 2019, and we are 45 questions here. So let's start the session. The first question is from the chapter Electric Charges and Fields, and the question is a hollow metal sphere of radius r is uniformly charged, then the electric field due to the sphere at a distance small r from the center is. Okay, so here we have a sphere that is uniformly charged, and this is hollow sphere, so all the charges will be distributed on the surface only. Okay, no charge will be present inside the sphere. Now we have to find the electric field at a distance small r from the center. So if this is the center, then we have two conditions. Either this distance r can lie somewhere inside the circle, or it can lie somewhere outside the circle, right? Now if this is the radius, then in case 1, that means when the point is inside the sphere, this r will be less than capital R, that means it will be smaller than the radius. Whereas in case 2, where the point lies outside the sphere, this r will be more than the radius. Okay, now we know that according to the Gauss law, integration of vector E dot vector ds gives q, that means charge, by epsilon naught. Okay, so in case 1 we know that the charge inside the hollow sphere is 0. Okay, so in case 1 q is equal to 0, so what will be the value of E dot ds? It will also be 0. Okay, so vector E will also be 0. So in first case the value of electric field will be 0. Okay, now we come to the second case. Here again the same formula will be used. So let's put the values. Vector E dot ds is what? Surface area. So it will be 4 pi r square. Okay, and that will be equal to charge by epsilon naught. So if we write it 4 pi r square this side, then it will be vector E equals to q by epsilon naught, and here 1 by 4 pi r square. So what do we see here? That the electric field is inversely proportional to the r square. Okay, that means it will decrease as the r will increase. Okay, so which option will be the correct one? First one, 0, as r increases for r less than r. That means when this r is less than capital R, this case 1, then it will be 0. So yes, and then in second case when r is more than capital R, then it will decrease as small r increase. Okay, because this is inversely proportional. So option A will be the correct answer. Now the next question is from the chapter Work, Energy and Power, and the question is, a force F equals to 20 plus 10y acts on a particle in y direction where F is in Newton and y is in meter. Work done by this force to move the particle from y equals to 0 to y equals to 1 meter is. Okay, so what is given here? Force is given as 20 plus 10y, and we have to find out the work done. So work done will be equal to integration of f dot dy, and the limit is 0 to 1. The value of f is 20 plus 10y. So let's put this value here. 20 plus 10y dot dy, and the limit is 0 to 1. So when we integrate 20 dy, we'll get 20y, and the limit is 0 to 1, plus integration of 10y dy will give 10y square by 2. Again the limit is 0 to 1. So here if we put the value y equals to 1 minus y equals to 0, then we'll get 20 only, plus here 2 into 5 is 10, so 5. And again if we put the value y equals to 1 minus y equals to 0, then again we'll get 1 only here, so 5 into 1 will be 5. So 20 plus 5 will be 25. Okay, so this is the work done, 25 joule. So option B will be the correct answer. Now question number 48 is from the chapter Current Electricity, and the question is, 6 similar bulbs are connected as shown in the figure with a DC source of EMF E and 0 internal resistance. Then the ratio of power consumption by the bulbs when number 1 all are glowing, and number 2 in the situation when 2 from section A and 1 from section B are glowing will be. Okay, so first of all we have to find out the power consumed in these two cases. Okay, case 1 and case 2. So in first case all the bulbs are glowing. Okay, So we can see that 3 bulbs are connected in parallel in section A. Similarly, 3 bulbs are connected in parallel in section B. Okay. So what will be the effective resistance for section A? Section A will be R by 3 because 3 are connected in parallel. Okay. Similarly, the effective resistance for section B will also be R by 3. Now the total effective resistance will be for total A plus B will be R by 3 plus R by 3 because these two are connected in series. Okay. So it will be 2R by 3. Now the formula for power is E square by R. So here it will be R effective. So we'll put the value of R effective as 2R by 3. So it will be E square by 2R and 3 will go up. So 3 E square by 2R. Okay. So this is the power in first case. So this is number 1. Now in case 2, only 2 from section A are glowing. Okay. So R effective for section A will be R by 2 because only 2 are connected in parallel. Okay. Third one is not working. Now for section B, R effective will be what? Section B. How many are glowing? Only 1. So it will be R only, right? So R effective of the combined section A plus B will be what? It will be R by 2 plus R because both are connected in series. So here we'll get what? 2 and then it will be 3R by 2, isn't it? So now power will be equal to E square by R effective again. So let's put this value here. E square by 3R and 2 will go up. So it will be 2 square by 3R. Okay, this is number 2. Now we have to find out the ratio. So let's find out the ratio here. P1 by P2 will be equal to 3E square by 2R into it will be 3R by 2E square. Okay. So here we'll get 9. E square will be cancelled. R will be cancelled. 9 by 4, that means the ratio will be 9:4. So what will be the correct answer? Option A will be the correct answer. Question number 49 is from the chapter Mechanical Properties of Fluids, and the question is, a soap bubble having radius of 1 millimeter is blown from a detergent solution having a surface tension of 2.5 into 10 to the power minus 2 Newton per meter. The pressure inside the bubble equals at a point Z0 below the free surface of water in a container. Taking G equals to 10 meter per second square, density of water 10 to the power 3 kg per meter cube, that means 1000 kg per meter cube. The value of Z0 is, okay. So let's see what is given in the question. We have a container which is filled with water, okay. Now inside this container a soap bubble is present at a point that is Z0 from the free surface. That means this height is equal to Z0, right? Now what will be the total pressure inside the soap bubble? Let's write it down here. Total pressure in the soap bubble is equal to atmospheric pressure plus excess pressure. So atmospheric pressure is taken as P0 and excess pressure inside the soap bubble is equal to 40 by R. Okay. So this is the total pressure inside the soap bubble. So this is suppose equation number 1. Now we know that inside a liquid the gauge pressure at a certain height is given as rho GH, okay, where rho is the density of the liquid. So here it will be the density of water, okay. G is the acceleration due to gravity and H is the height from the surface of the water, okay. So here density is given as 1000, G is equal to 10 meter per second square and height is equal to Z0, right? So let's write it down here. Pressure inside the liquid, that means water, will be equal to atmospheric pressure plus gauge pressure. Okay. Again, atmospheric pressure will be equal to P naught and gauge pressure will be equal to rho GH, and here H is equal to Z naught. So rho G Z naught. Okay, now let's assume this is equation number 2. So what is given in the question? At this point, that means at a point Z naught, both these pressures become equal. Okay, so 1 become equal to 2. That means P naught plus 40 by R become equal to P naught plus rho G Z naught. Okay, so P naught will be cancelled because it is on both sides, and we have to find out the value of Z naught, right? So Z naught will be equal to 40 by R divided by rho and G. Okay, so let's put the values here. 4T, that means 4 into T is the surface tension, so it is given as 2.5 into 10 to the power minus 2. 2.5 into 10 to the power minus 2 divided by R is the radius, so it is given as 1 millimeter, that means 10 to the power minus 3 meter. Rho is the density, it is given as 10 to the power 3 again, 10 to the power 3, and G is the acceleration due to gravity, it is given as 10. So in solving this, we'll get 10 to the power minus 2 meter. Okay. Now we know that 10 to the power minus 2 meter will be equal to 1 centimeter. So either 10 to the power minus 2 meter or 1 centimeter will be the answer. So here the options are given in centimeters. So option B will be the correct answer, 1 centimeter. Question number 50 is from the chapter electromagnetic waves, and the question is, which color of the light has the longest wavelength? Options are blue, green, violet and red. So it is a known fact that red color has the longest wavelength, right? And it is approximately 700 to 635 nanometer. Okay, that's why we write VIBGYOR, that means in the increasing order of wavelength. Okay, so red has the maximum. So which has the minimum? It is violet. Okay, so violet color has minimum wavelength and it is about 450 to 400 nanometer. Okay, if we talk about the blue color, it is slightly more than that of violet, so it is 490 to 450 nanometer, whereas green color is even more, so it is about 560 to 520 nanometer. Okay. Question number 51 is from the chapter gravitation, and the question is, a body weighs 200 Newton on the surface of the earth. How much will it weigh halfway down to the center of the earth? Okay, so what does the question say? Suppose this is the earth, this is the center of the earth O, okay, and this is the surface of the earth. So we have to find out the weight of a body at a point that is halfway down center of the earth. Okay, that means if we move down the surface of the earth towards the center, then we have to find out the weight at a point. Suppose this is point D, that is halfway. That means if this is the radius, then this point D is half of the radius. So it is equal to R by 2. Okay. Now we know that weight of a body is equal to the product of mass and acceleration due to gravity. Okay, and we also know that the mass remains constant irrespective of the position, so the weight will vary with acceleration due to gravity. Okay, because this always keeps changing with the position. So let's see how does the acceleration due to gravity vary. G dash, that means new acceleration due to gravity, will be equal to G 1 minus d by r. Okay, D is the point at which we have to find out the acceleration due to gravity or weight. Okay, so this is suppose equation number 1. So we know that mg dash, that means new weight, will be equal to mg 1 minus d by r, and we know that d is equal to r by 2, so we can put this value here, mg 1 minus r by 2 into r. Okay, so this is cancelled and here we have mg 1 minus half, so it will be half mg. Okay, so mg dash will be half of mg, that means initial weight. So mg was given as 200 Newton. So half of 200 Newton will be what? 100 Newton. So the new weight will be 100 Newton. Therefore option C will be the correct answer. Question number 52 is from the chapter Mechanical Properties of Fluids, and the question is, a small hole of area of cross section 2 mm square is present near the bottom of a fully filled open tank of height 2 meter. Taking the value of G as 10 meter per second square, the rate of flow of water through the open hole would be nearly. Okay, so we have a container whose height is given as 2 meter. Okay, this is the tank. Now this has a hole near bottom whose area of cross section is 2 mm square. So we know that 1 millimeter is equal to 10 to the power minus 3 meter. So 1 millimeter square will be what? 10 to the power minus 3 square. That means 10 to the power minus 6 meter square. So the area is 2 millimeter square. So it will be equal to 2 into 10 to the power minus 6 meter square. Okay. So in meter square it will be 2 into 10 to the power minus 6. And this is the value that we have to use in the equation. We have to find out the rate of flow of water, that is Q. So that is equal to area of cross section of the hole into velocity of water. Okay. And velocity of water is what? Root 2gh. Okay, h is the height of the tank. So let's put the value here. Area of cross section is 2 into 10 to the power minus 6 meter square. Then under root 2 into 10, because the value of g is 10 and height is 2 meter. Okay, so on solving this, what will we get? We'll get 2 into 10 to the power minus 6 into 2. These two will come out as 1 2. Okay, and then under root 10. So here we'll get 4 into 10 to the power minus 6 into 3.16. Root 10 is almost equal to 3.16. So on solving this, we'll get 12.6 into 10 to the power minus 6. Okay, and the unit will be meter cube per second. So out of the given options, option D will be the correct answer. Question number 53 is from the chapter Systems of Particles and Rotational Motion, and the question is, a disk of radius 2 meter and mass 100 kg rolls on a horizontal floor. Its center of mass has speed of 20 centimeter per second. How much work is needed to stop it? Okay, so we have to stop it. That means the final velocity is going to be 0. Okay, and here the speed is given as 20 centimeter per second. That means it will be 20 into 10 to the power minus 2 meter per second. Okay, and this is what we have to use. Now we have to find out the work done. So work done is given as change in kinetic energy. That means final kinetic energy minus initial kinetic energy, right? And here we know that the final velocity is 0. So the final kinetic energy will also be 0. That means the work done will be equal to the initial kinetic energy only. Okay. We'll ignore the minus sign because we have to focus on the magnitude. Okay. Now here two types of motions are there. Translational as well as rotational. Okay. So kinetic energy will be the sum of translational kinetic energy. Translational plus rotational, okay, plus rotational kinetic energy. Translational kinetic energy will be half mv square and rotational kinetic energy will be half I omega square. Okay, so what will be the value of I? That means moment of inertia for a circular disc. See, let's write it here. For a circular disc, the value of I is equal to mr square by 2, that, or we can say half mr square. Okay, so we'll put this value here, mr square by 2. Okay, and omega, we know that it is equal to v by r. So here we have omega square, that means v square by r square. Okay, so let's solve this. This r square will be cancelled. Okay, so what will we get here? Half mv square plus 1 by 4 this side, 2 into 2 is 4 mv square. Okay, so half mv square plus 1 by 4 mv square will be 3 by 4 mv square. Okay, now we can put the value here. 3 by 4, m is the mass, so mass is given as 100 kg, 100 kg, and velocity is given as 20 centimeter per second, or 20 into 10 to the power minus 2 meter per second. So we'll write in meter, therefore it will be 20 into 10 to the power minus 2 meter per second. Okay, and it is in kg. Now it will be, this will be 400 and this will be 10 to the power minus 4. So on solving this, what will we get? We'll get 3. Okay, and the unit will be joule for work. So 3 joule of work will be required to stop this. So option D will be the correct answer. Okay, if you want to see how we have got 3 joule, then I can solve this here. 3 by 4 into 100 into 400, this square of 20 will be 400 into 10 to the power minus 4. Okay, so here 4, here we get 100. So 3 into 10 to the power 4 into 10 to the power minus 4. So it will be cancelled. What will we get? 3 only. Okay, therefore 3 joule. Question number 54 is from the chapter Ray Optics and Optical Instruments, and the question is, two similar thin equiconvex lenses of focal length f each are kept coaxially in contact with each other such that the focal length of the combination is f1. When the space between the two lenses is filled with glycerine, which has the same refractive index as that of glass, then the equivalent focal length is f2. The ratio f1 is to f2 will be. Okay. So let's see what is given here. We have two lenses. Both are made up of glass, right? This is also glass and this is also glass with the same refractive index, that is 1.5. And the focal length of each lens is small f. And the focal length of the combination is what? Capital F1. So in case 1, 1 by f1 will be equal to 1 by f plus 1 by f. Okay, so here we'll get 2 by f. So what will be the value of f1? It is equal to f by 2. Okay, so this is the first value that we have to note. Now in the second case, case 2, the space between the lenses is filled with glycerine. Okay, so this is filled with glycerine and it has also the same refractive index, that is 1.5. So what will glycerine do? It will act as a diverging lens. Okay, act as diverging lens of focal length. The magnitude will be same, that is small f, but it will be minus f. Okay, because it is acting as a diverging lens or concave lens. Okay, so this time we have three focal lengths, f, f and minus f. So 1 by f2 will be equal to 1 by small f plus 1 by small f minus 1 by small f for glycerine. Okay, so these two will be cancelled, so only 1 by f will be left. Okay, so what will be the value of f2? It will be small f only. Now we have to find out the ratio of these two. Okay, so f1 by f2 will be equal to f by 2 divided by f, that means half. Okay, so the ratio of these two focal lengths will be half, that means option A, 1:2. Okay. Question number 55 is from the chapter Units and Measurement, and the question is, in an experiment, the percentage of error occurred in the measurement of physical quantities A, B, C and D are 1%, 2%, 3% and 4% respectively. Then the maximum percentage error in the measurement X, where X is equal to this quantity, will be. Okay, so we have to find out the maximum percentage error, right? Maximum percentage error. So that will be the sum of the percentage errors of each of these quantities. Okay, so maximum percentage error, that means delta x by x, will be equal to the sum of the percentage errors, that means delta a by a into 100. This is the percentage error of a, plus delta b by b into 100, that is percentage error of B, plus delta C by C into 100, that is the percentage error of C, plus delta D by D into 100, that is percentage error of D. Now here we can see we have A square, that means the percentage error of A will be twice. Okay. Similarly, we have B to the power half, that means it will be half into the percentage error of B. Okay. For C we have 1 by 3, that means it will be 1 by 3 times the percentage error of C, and for D we have cube, that means 3 times the percentage error of D. Okay, so let's put the values. The percentage error of A is given as 1%, so we have 2 into percentage error, that means 2 into 1%, plus this is half into 2 because percentage error of B is 2, so half into 2. Okay, plus for C we have 1 by 3 into the percentage error of C is 3%. So 3 plus 3 into percentage error of D, that is given as 4%. Okay. So 2 into 1 is 2, plus half into 2 will be cancelled. This will be 1. 3 cancelled. So it will also be 1, plus 3 into 4 will be 12. Okay. So 2 plus 1, 3 plus 1, 4 plus 12 will be 16. So the maximum percentage error will be 16%. That means option A will be the correct answer. Question number 56 is from the chapter Thermal Properties of Matter, and the question is the unit of thermal conductivity is. Okay, so we know that thermal conductivity is denoted by capital K, and what is the formula in which thermal conductivity is used? It is used in the formula of heat current dH by dt. Okay, this is heat current and it is given as Ka delta T divided by L. What is K here? K is the thermal conductivity of the material. Conductivity. A is the area of the conducting material. L is the length of the conducting material. And delta T is the change in temperature. Okay. So this is temperature change. And it is written in Kelvin. So now we have to find out the unit for thermal conductivity K. So K will be equal to what? dH by dt into L by A delta T, right? Now we'll write the units of these. So what will be the unit of dH by dt? See, we know that the unit of heat is same as that of work, that is joule. So dH by dt can be written as dW by dt, where W is the work done. And what is the rate of work done? It is power. So the unit of dH by dt will be same as the unit of power. What is the unit of power? It is watt. Okay, it is written as W. So here we'll write W. Okay. What is the unit for length? It is meter. Unit for A will be meter square. Unit of delta T, change in temperature, will be Kelvin. So 1m cancelled. What will be left? W by m into K. Okay. So we can write it as W m minus 1, that means per meter per Kelvin. Okay. So watt per meter per Kelvin. That means option C will be the correct answer. Question number 57 is from the chapter Gravitation, and the question is the work done to raise a mass small m from the surface of the earth to a height h which is equal to the radius of the earth is. Okay. So suppose this is the earth, this is the center of the earth, then this will be the radius of the earth. Okay, capital R will be the radius of the earth, and we have to raise a mass to a certain height h from the surface of the earth such that this height is equal to the radius of the earth. Okay. Now this is point P. Now what do we have to find out? We have to find out the work done, and according to the work energy theorem, work done is equal to change in potential energy. That means final potential energy minus initial potential energy. Okay. So final potential energy will be minus gmm by r plus h, because the total distance of this point P from the center will be r plus h. Okay. Minus initial potential energy, that means minus gmm divided by r only. Okay. So here we know that h is equal to r. So minus gmm by R plus R will be 2R. Okay. Minus minus will become plus. Here we have GMM by R. So if we take the LCM, then 2R will be here. Here we have minus GMM plus 2GMM. Okay. So what will we get here? We'll get GMM by 2R. Now we know that small g is equal to capital G into mass of the earth divided by R square. Okay. So to get R square, we'll multiply and divide this with R. So here we'll get GMM R divided by 2R square, right? Now we know that G capital M by R square is equal to small g. So it can be written as small g M R divided by 2 or half mgr, right? That means the work done will be equal to half mgr. That means option B will be the correct answer. Question number 58 is from the chapter Thermodynamics, and the question is, in which of the following processes heat is neither absorbed nor released by a system? So it is very simple and direct question. We know that in case of adiabatic system, heat is neither absorbed nor released. Okay, so no change of heat takes place. Okay, if we talk about isobaric, then in this case, no change of pressure takes place. Okay, that means pressure remains same. In isochoric, volume remains same. And in case of isothermal, the temperature remains same. So according to the question, the correct answer will be the first one, adiabatic. Question number 59 is from the chapter Electric Charges and Fields, and the question is, 2-point charges A and B having charges plus Q and minus Q respectively are placed at certain distance apart and force acting between them is capital F. If 25% of charge of A is transferred to B, then force between the charges becomes, okay. So we have two charges, one is plus Q and the other is minus Q. They are separated by a certain distance, suppose small r. Okay, so we know that according to the Coulomb's law, force is given as K into Q1 Q2 by R square, where R is the distance between the two charges. So here Q1 and Q2 both are same, so it can be written as K into Q square by R square, right? So this is one important thing that we have to keep in mind. Now here it is given that 25% of charge of A is transferred to B. 25% means 1/4. Okay. So QA will become what? Q minus Q by 4. Okay. Because Q by 4 has been removed. So what is left after that? Here we'll get 3 by 4. Okay. So 3 by 4 Q will be left. And what will be the QB? QB will accept this Q by 4 charge. So it will become minus Q plus Q by 4. Okay. So it will be minus 3 by 4Q. Okay. Now this time what will be the force become? Force will become again K Q1 Q2 by R square. So here we'll write the magnitude only, not the sign. So K Q1 is 3 by 4Q. 3 by 4Q. Q2 is also 3 by 4Q divided by R square. Okay. So we'll get here 9 by 16 K Q square by R square. And we know that KQ square by R square is equal to initial force F. So it can be written as 9 by 16 F. Okay. That means option A will be the correct answer. Question number 60 is from the chapter Semiconductor Electronics, and the question is, the correct Boolean operation represented by the circuit diagram drawn is, okay. So this is the circuit diagram and we can see that two switches are there, switch A and switch B, okay. In off condition the value of switch will be 0 and in on condition the value will be 1, okay. Then there is an LED here. So under what condition this LED will glow? It will glow when the voltage across this LED is high, okay. So it will glow when the voltage across the LED is high. Now, another thing to note here is that there are two paths for currents to follow. This is path number 1, okay, across the LED straight. So this is first path through which the current can move, and the other path is through the switches, okay, this path, path number 2, okay. So let's see. We have two types of inputs from A, inputs from B, and Y will give us the output, okay. So in the first condition, let's assume that both the switches are off, okay. So in that condition, the input will be 0 for both, okay. So what will happen when both the switches are off? The current will come here and it will be blocked here because the switch is off, so it cannot move further. That means the current will not follow the second path. So the current has only one option, it will move through the first path, that means through the LED. So in this case the voltage will be high, so the LED will be glowing, okay. So the output will be 1 because LED glows, okay, it glows. Now in second condition, let's assume that switch A is on, switch B is off. Okay, so 1, 0. Now in this case, current will again come here. It will pass through the first switch because this is on. But when it comes towards the switch B, again it will be stopped. Okay, because this switch is off. Again, current will not be able to follow this complete path. So it will move through the first path only. So again the output will be 1 because the LED will glow. Okay. Similarly, in the third condition, A is off, B is on. Again, even if any one is off, then the current will not be able to follow the second path. Okay, it will follow the first path only. So again, the LED will glow. Now in the last condition, when both the switches are on, in that condition, the value of A and B will be 1. So current will follow this path only, path 2, because there is no obstacle in its path. So this time current will not follow path 1. Therefore, the voltage across LED will be low. That means it will be 0. The LED will not glow. Okay. Now looking at this truth table, you can understand that this is the characteristic of NAND gate. Okay. NAND gate. Therefore, the correct option will be option number B, NAND. Question number 61 is from the chapter Heating Effects of Electric Current, and the question is, which of the following acts as a circuit protection device? Options are inductor, switch, fuse and conductor. So again, this is a very direct question. We know that electric fuse is used as a circuit protection device, and what is the reason? The reason is the low melting point of fuse wire. Okay, that means it melts easily. So let's write it down here. Fuse wire has a low melting point, so when excess current is passed, or flows, then what happens? See, this current pass, then heat increases, right? So due to heat production in the wire, due to heat production in it, it melts, and this way it protects the other devices. Okay, so option C will be the correct answer. Question number 62 is from the chapter Thermal Properties of Matter, and the question is, a copper rod of 88 centimeter and an aluminium rod of unknown length have their increase in length independent of increase in temperature. The length of aluminium rod is, okay, so the length of copper is given and we have to find out the length of aluminium rod. Okay, so what will be the new length of copper rod after expansion? LCU dash will be equal to the initial length of copper rod, LCU, 1 plus alpha Cu delta T. Okay. Similarly, the new length of aluminium rod, L dash of aluminium, will be equal to the initial length of aluminium, 1 plus alpha aluminium delta T. Okay. Now, we know that before and after the expansion, the difference in length will remain same. Okay, so the initial difference will be equal to final difference. What is the initial difference? Initial difference is L of aluminium minus L of copper. And what is the final difference? L dash of aluminium minus L dash of copper. So what is L dash of aluminium? From here we can see it is equal to initial length of aluminium rod 1 plus alpha aluminium delta T minus L dash of copper, that means this one. So L of copper 1 plus alpha copper delta T. Okay. So now if we solve the right hand side by opening the brackets, we'll get length of aluminium rod plus L aluminium alpha aluminium delta T minus length of copper minus length of copper aluminium alpha of copper delta T. Okay. So now we can write length of aluminium minus length of copper together, and then what is left here plus length of aluminium alpha aluminium minus length of copper alpha of copper, and delta T can be taken as common. Okay. So this is same as the initial difference in the length of aluminium and copper rod. So we can see that L aluminium minus L copper is on both the sides of the equal sign. So it will be cancelled. So what is left here? Here we get L aluminium alpha aluminium minus L copper alpha copper delta T equals to 0. Okay. Now it is given that the increase in length is independent of increase in temperature. So delta T has nothing to do here. Okay. So simply L aluminium alpha aluminium will be equal to minus L copper alpha copper will be equal to 0. So we can write that L of aluminium alpha of aluminium will be equal to L of copper alpha of copper. Right. Now we can put the values to find out the length of aluminium. Okay. So length of aluminium will be what? Length of copper alpha of copper divided by alpha of aluminium. So all these three quantities are already mentioned here. Length of copper is given as 88 centimeter. So 88 into alpha of copper is what? It is 1.7 into 10 to the power minus 5. So 1.7 into 10 to the power minus 5. Okay. Divided by alpha of aluminium, that is 2.2 into 10 to the power minus 5. So on solving this, what do we get? We'll get 68 centimeter. So the correct option will be option number C, 68 centimeter. Question number 63 is from the chapter Electrostatic Potential and Capacitance. And the question is, a parallel plate capacitor of capacitance 20 microfarad is being charged by a voltage source whose potential is charging at a rate of 3 volt per second. Okay. The conduction current through the connecting wires and the displacement current through the plates of the capacitor would be respectively. Okay. So what is given here? The capacitance is given. So C is equal to 20 microfarad, and then the change in potential is given, that means dV by dt is given as 3 volt per second. What we have to find out? We have to find out the conduction current, that means IC, as well as displacement current, that means ID. Okay. Now it's very simple. We know that charge is given as the product of capacitance and voltage or potential difference. Okay. So dq by dt, the differentiation of charge, will be equal to C dV by dt, because capacitance will remain constant. Now we know that dq by dt is nothing but current. Okay. So it is current, that means IC, conduction current, and that is equal to C dV by dt, C dV by dt. Okay. Now what is the value of C? It is given as 20 microfarad. 20 into 10 to the power minus 6 farad. Okay. And dV by dt is given as 3 volt per second. 3 volt per second. So on solving this, we get 60 into 10 to the power minus 6, and the unit of current will be ampere. So this is the value of conduction current. Conduction current. Now we also have to find out the displacement current. So we know that that both are actually same. Okay, the displacement current is always equal to the conduction current. Therefore, displacement current is also equal to 16 to 10 to the power minus 6 ampere, or we can say 60 microampere. Okay, so what is the conduction current? It is 60 microampere, and the displacement current is also 60 microampere. So option number A will be the correct answer. Both are equal. Question number 64 is from the chapter atoms, and the question is alpha particle consists of. Okay, so out of the given options we have to find out the right composition of alpha particle. So how do we write alpha? Alpha particle is written as alpha 4 2 or helium 4 2. Okay, that means atomic number of alpha particle, this lower one, is 2, and atomic number is nothing but number of electrons or protons. So number of electrons or protons in alpha particle is equal to 2. Now what is the mass number? Mass number, the upper one, it is equal to 4, and mass number is nothing but number of protons plus number of neutrons. Okay, so the sum of these two is equal to 4, and we know that number of protons is 2. So 2 plus number of neutron is 4. So what is the number of neutrons? It is equal to 4 minus 2, that means 2. That means number of proton is 2 and number of neutron is also 2. So the last one, option D, will be the correct answer. 2 protons and 2 neutrons only. Question number 65 is from the chapter friction, and the question is a block of mass 10 kg is in contact against the inner wall of a hollow cylindrical drum of radius 1 meter. The coefficient of friction between the block and the inner wall of the cylinder is 0.1. Then the minimum angular velocity needed for the cylinder to keep the block stationary when the cylinder is vertical and rotating about its axis will be. Okay, so what is given here? Mass of the block is given as 10 kg. Then radius of the cylindrical drum is given as 1 meter. Coefficient of friction, that is mu, is given as 0.1, and we have to find out the value of angular velocity, that means omega. Okay, G is to be taken as 10 meter per second square. So we have a cylindrical drum, hollow cylindrical drum. So suppose this is the cylindrical drum we are talking about, and then a block of mass m is kept here, and it is moving like this. Okay, cylinder is moving. So let's draw the free body diagram of this block. So we know that there are several types of forces acting here. One force will be acting downwards, and that is equal to mg. This is the weight of the block. Okay, similarly one force will be acting just opposite to mg, that will be equal in magnitude. Okay, so it is frictional force. Then normal will be acting towards inside of the drum, and then opposite to normal, centrifugal force will be acting, suppose Fc. Okay, so we know that the magnitude of mg will be equal to the magnitude of frictional force. Similarly, the magnitude of normal will be equal to magnitude of centrifugal force, because two will balance each other. Okay, so in first case, mg will be equal to frictional force, and frictional force is equal to mu into n. Okay, that you have to remember. So what will be the value of n? It will be equal to mg divided by mu. What is m? It is 10 kg. G is 10 meter per second square. Then mu is given as 0.1. Okay, so in solving this we get 1000, and the unit will be Newton. So now we have got the value of normal n. Also we know that normal will be equal to the magnitude of centrifugal force. Okay, Fc. And centrifugal force is given as m omega square r. Okay, so omega will be root of n divided by m into r. Okay, from here, so let's put the values here. N is given as 1000, we have just calculated. M is given as 10 kg, and r is 1 meter. Okay, so that will be equal to root 100, that means 10, and the unit will be radian per second. So the correct answer will be 10 radian per second. It is the angular speed. That means option C will be the, option B will be the correct answer because we don't have pi here. So option B will be the correct answer. Question number 66 is from the chapter Kinetic Theory, and the question is, increase in temperature of a gas filled in a container would lead to. Options are increase in its kinetic energy, decrease in its pressure, decrease in intermolecular distance, and increase in its mass. Okay, so the correct option will be the first one, increase in its kinetic energy. Okay, so there is a logic behind that. Suppose we have a container and there are gas molecules here. So on increasing the temperature, what will increase? Thermal energy will increase. Okay, so let's write it down here. On increasing the temperature, thermal energy will increase. And when thermal energy will increase, that means the molecules will acquire more energy, then they'll move fast. Okay, therefore kinetic energy of the molecules will also increase. Okay, and then we have a formula also. We know that kinetic energy of the molecules is equal to 3 by 2 R upon Na into T. R is the gas constant, N is the Avogadro number, and T is the temperature. Okay, so we can see that kinetic energy is directly proportional to the temperature. That means when temperature increases, kinetic energy will also increase. Okay, when temperature increases, kinetic energy will also increase. Therefore option A will be the correct answer. Question number 67 is from the chapter Electromagnetic Induction, and the question is, a 800-ton coil of effective area 0.05 meters square is kept perpendicular to a magnetic field 5 into 10 to the power minus 5 Tesla. When the plane of the coil is rotated by 90 degree around any of its coplanar axis in 0.1 second, then the EMF induced in the coil will be. Okay, so what is given? Magnetic field is given as 5 into 10 to the power minus 5 Tesla. Number of turns N is given as 800. Effective area of the coil is given as 0.05 meters square. Now if we talk about the angles theta 1 and theta 2, then it is given that the plane of the coil is rotated by 90 degree around any of its coplanar axis in 0.1 second. That means the initial angle was 0 degree and final angle is 90 degree. Okay, time is given as 0.1 second. Now we have to find out the induced EMF, and EMF is equal to minus delta phi by delta t. Okay, that means change in rate of change of flux. And what is phi? Phi is the magnetic flux, that is given as NBA cos theta for n number of turns. B is the magnetic field and A is the area. So here first we'll find out the change in magnetic flux delta phi. So it is equal to phi 2 minus phi 1, right? What will be phi 2? It will be NBA cos theta 2. Similarly phi 1 will be NBA cos theta 1. Okay. Now we can take NBA common, NBA, and under bracket cos theta 2 minus cos theta 1. Okay. So we can put the values here. N is the number of turns, it is 800. B is the magnetic field, 5 into 10 to the power minus 5 Tesla. A is the effective area, 0.05 meter square. Cos theta 2 means cos 90 degree minus cos theta 1, that is cos 0 degree. Okay. So here if we solve, we'll get 2 into 10 to the power minus 3, and under bracket cos 90 degree means 0, cos 0 degree means 1. So it will be minus 2 into 10 to the power minus 3, and the unit will be Weber, right? Now we have got the delta phi. So we can find out the EMF also. EMF is equal to minus delta phi by delta t. That means minus delta phi is minus 2 into 10 to the power minus 3 Weber divided by delta t. So the time taken is 0.1 second. So here this minus will be plus. So what will we get here? It will be 0.02 volt. Okay. So the correct answer will be option number C, 0.02 volt. Question number 68 is from the chapter Electric Charges and Fields, and the question is two parallel infinite line charges with linear charge densities plus lambda coulomb per meter and minus lambda coulomb per meter are placed at a distance of 2r in free space. What is the electric field midway between the two line charges? Okay, so we have two line charges here. The charge density on one is plus lambda and that on the other is minus lambda, right? The distance between them is 2r. And we have to find out the electric field midway, that means at this point. So the distance of this point from each charge infinite line charge will be r. Okay, now what is the formula for electric field due to infinite line charge? It is 2k lambda by r, right? K is a constant and that is equal to 1 by 4 pi epsilon naught. Now the electric field due to the positive line charge, that means E1 will be what? 2k lambda by r I cap, and E2 will be 2k minus lambda minus I cap by r. Okay, because it is in the charge density is minus and the direction is also opposite, so minus I cap. Now this minus minus will be cancelled, it will become plus, so it will also become 2k lambda I cap by r. Okay, so what will be the net electric field? E net will be equal to E1 plus E2. That means 2k lambda I cap by r plus 2k lambda I cap by r. Okay, so it will become 4k lambda I cap by r. Now we can put the values. 4 into k is what? 1 by 4 pi epsilon naught lambda by r. Okay, so here 4 cancelled, so it will be lambda by pi epsilon naught r. Okay, that means which option should be the correct one? Option number B, lambda by pi epsilon naught r, and the unit will be Newton per coulomb. So option B will be the correct answer. Question number 69 is from the chapter Ray Optics and Optical Instruments, and the question is, in total internal reflection, when the angle of incidence is equal to the critical angle for the pair of media in contact, what will be the angle of refraction? Options are 0 degree, equal to the angle of incidence, 90 degree and 180 degree. So the correct option will be option number C, that is 90 degree. Okay. So we have two media here, medium 1 and medium 2. This is the surface and this is the normal to the surface, right? Now we know that in case of total internal reflection, the first medium is always a denser medium and the other medium is a rarer medium, right? Now when a ray of light strikes the surface making an angle with the normal, this is known as angle of incidence, right? So there are three situations possible here. Okay, in the first case, what can happen? Angle of incidence can be less than the critical angle. So IC is the critical angle. So in this case, what will happen? This ray of light will move away from the normal in another medium. Okay, that means refraction will take place. It will get refracted in the other medium. So refraction will take place here. Now the second condition is that the angle of incidence will be equal to the critical angle. Okay, that means what will happen? This time the ray of light will graze along the surface. Okay, it will graze with the surface this way. So it will make 90 degree angle with the normal. Okay, this is the 90 degree. Now the third and the last case is when the angle of incidence will be more than the critical angle. So in this case, what will happen? This will move inside the same medium. That means it will get totally reflected. Okay, so total internal reflection will take place. Total internal reflection will take place. Okay, so in this question, it was asked about the second condition. Therefore, in this case, the angle of refraction will be 90 degree. Okay, angle of refraction will be 90 degree. Question number 70 is from the chapter Dual Nature of Radiation and Matter, and the question is, an electron is accelerated through a potential difference of 10,000 volt. Its de Broglie wavelength is, okay, mass of the electron is given as 9 into 10 to the power minus 31 kg. Okay, so we don't have to do anything with the mass of the electron because we have simple formula to find out the de Broglie wavelength. Okay, we know that for an electron accelerated through a potential V. What is the formula for de Broglie wavelength? It is equal to 12.27 by root V angstrom. Okay, root V is the root of potential difference. So let's put the value of potential difference. It is given in the question. So 12.27 divided by under root 10,000. And here we have angstrom. We have to convert it in meter. So we know that 1 angstrom is equal to 10 to the power minus 10 meter. So let's multiply it with 10 to the power minus 10. Now on solving this, we'll get 12.27 into 10 to the power minus 12 meter. So this is the de Broglie wavelength. That means option A will be the correct answer. Okay. Question number 71 is from the chapter Moving Charges and Magnetism, and the question is, a cylindrical conductor of radius capital R is carrying a constant current. The plot of the magnitude of magnetic field capital B with the distance small d from the center of the conductor is correctly represented by the figure. Okay, so we have to find out the correct plot. Now if we talk about a cylindrical conductor, that means it is carrying current, then what will happen? Suppose this is the center and this is the radius. Okay, then there are three situations. This distance d from the center of the conductor can lie somewhere inside the cylinder. Okay, so this is condition 1. If this is the distance d, then this distance will be less than the radius, right? So in case 1, what will happen? This d will be less than the radius r. Okay, so in this case what will happen? The magnitude of magnetic field will be equal to mu naught I by 2 pi r square d. Okay, I is the current, mu naught by 2 pi is the constant, and r is the radius. Okay, so we have to find out the relation between magnetic field and this distance only to find the plot. So we can see that B is directly proportional to the distance D. Okay, so this is the first case. Now in case 2, this distance will be exactly equal to the radius. That means the point will lie on the wall of the container. Okay, so this will be same as the radius. Okay, in this case the magnitude of magnetic field will be equal to mu naught I by 2 pi r. Okay, now here the magnetic field will be maximum. Okay, maximum magnetic field. Now in the third and the last case, this point can lie somewhere outside the cylinder. So this distance d will become more than that of radius. Okay, so in this case d will become more than the radius, and the magnitude of magnetic field will be equal to mu naught I by 2 pi d. Okay, that means the magnetic field will be inversely proportional to d. Okay, so we can see that before r, before the radius, it is directly proportional to d, and after that it is inversely proportional. So if we draw a graph here, and this is the radius capital R, then from center to radius this will be directly proportional. That means it will increase like this. There will be a straight line, and after that it is inversely proportional, so it will be a hyperbola. Okay, this is 1 by d and this is d. Okay, b proportional to d and b proportional to 1 by d. Okay, so which option will be the correct one? Option number B will be the correct answer. Question number 72 is from the chapter Ray Optics and Optical Instruments, and the question is, pick the wrong answer in the context with rainbow. Okay, so we have to find out the incorrect option. Now the first statement says the order of colors is reversed in the secondary rainbow. So this is a correct statement. What is a secondary rainbow? Secondary rainbow is caused by the second reflection. Okay, so secondary rainbow is a faint rainbow formed by light rays that undergo that undergo two internal reflections. Okay, two internal reflections in rain drops of rain appearing above the primary rainbow. Okay, so secondary rainbow always appears above the primary rainbow, and having its its colors in the opposite order. Okay, opposite order. So what is the difference between primary and secondary rainbow? The secondary rainbow is faint as compared to the primary rainbow. Then it appears above the primary rainbow. And lastly, it has opposite orders of colors. Okay. So in primary rainbow, red color is on the top, red on top, violet is on the bottom side. Whereas in secondary rainbow, violet color appears at the top. Okay. Now, let's come back to the statements. First statement is that the orders of colors is reversed in the secondary rainbow. So this is true. Now, in the second one, it is said that an observer can see a rainbow when his front is towards the sun. Now, this is not a correct statement, okay? Because when you face the sun, you cannot see a rainbow. And what is the reason? Reason is that the center of the primary rainbow is opposite to the sun, okay? The center of primary rainbow is at the at anti-solar point. What is anti-solar point? The point just opposite to the sun, and this is an imaginary point. Okay. So if you face the sun, you will not be able to see the rainbow because the rainbow will be formed behind you. Okay. So this is the incorrect option. Now the third statement says rainbow is a combined effect of dispersion, refraction and reflection of sunlight. This is also true. And the last one says when the light rays undergo two internal reflections in water drop, a secondary rainbow is formed. So we have already seen that more than one internal reflection causes the formation of rainbow. So the only wrong answer will be option number B. So this will be the correct choice here. Question number 73 is from the chapter Atoms, and the question is the total energy of an electron in an atom in an orbit is minus 3.4 electron volt. Its kinetic and potential energies are respectively. Okay, so we can use the Bohr's model of hydrogen atom here. We should know that in Bohr's model of hydrogen atom, the total energy of the electron is equal to negative of kinetic energy. Okay. Also, it is half of potential energy. Potential energy by 2. Now, it is given that the total energy is minus 3.4 electron volt. So first we can find out the kinetic energy. We know that total energy is the negative of kinetic energy. That means kinetic energy will be equal to negative of total energy, right? So it will be equal to negative of minus 3.4 electron volt. So it will be minus minus plus, that means 3.4 electron volt. Okay. So this is the kinetic energy. Now second, we know that total energy is half of potential energy, U by 2. So what will be the value of potential energy? It will be equal to 2 times the total energy. That means 2 into minus 3.4 electron volt. So here we'll get minus 6.8 electron volt. So kinetic energy is 3.4 electron volt and potential energy is minus 6.8 electron volt. Okay. So the correct option will be option number B. Okay. First one is positive. Second one is negative. Option number B is the correct answer. Question number 74 is from the chapter Oscillations, and the question is the displacement of a particle executing simple harmonic motion is given by y equals to a naught plus a sine omega t plus b cos omega t. Then then the amplitude of its oscillation is given by. Okay, so this equation represents the superposition of two waves. What happens in superposition? The two waves are added. So here we can see that these two waves, this is wave A, this is wave B, are added here because these are superimposed on each other. And what is the role of A naught? A naught represents the shifting of mean position along the y-axis. For example, if this is x-axis, this is y-axis, and this is the particle executing SHM, then during the motion there will be shift in the mean position. So this shift of mean position along the y-axis is represented by A naught. Okay, but A naught does not affect the motion of the particle. Okay, so let's write it down here. Motion of the particle is unaffected by A naught. Okay, so we can just ignore this A naught. Let's write down an equation y dash such that it is equal to y minus A naught, because we want to ignore this A naught. So y dash will be equal to a sine omega t plus b cos omega t only. Now we have to find out the net amplitude. So for that, first we'll convert b cos omega t in terms of sine. Okay, because both should be same. Either both should be sine or both should be cos. So we are doing like this: a sine omega t plus b sine omega t plus pi by 2. Okay, if you remember some basic trigonometric functions, then you can understand this. So from here we understand that there is a phase difference of pi by 2. Okay, phase difference is pi by 2, that means 90 degree. Now how do we find the net amplitude? A net will be equal to under root a square plus b square plus 2ab cos theta. Okay, theta is the phase difference. Okay, now here we have under root a square plus b square plus 2ab cos 90 degree. 90 degrees cos 90 degrees 0. So here this will become 0. Okay, so what will be left here? Under root a square plus b square only. So the correct option will be option number A. Okay. Question number 75 is from the chapter Semiconductor Electronics, and the question is, for a p-type semiconductor, which of the following statements is true? Options are: holes are the majority charge carriers and trivalent atoms are the dopants. Option B: holes are the majority carriers and pentavalent atoms are the dopants. Then electrons are the majority carriers and pentavalent atoms are the dopants. And the last one is electrons are the majority carriers and trivalent atoms are the dopants. Okay, so the correct option will be option number A. That means holes are majority carriers and trivalent atoms are the dopants. Okay, so we know that there are two types of semiconductors, P type and N type, right? P means positive and N means negative. Now, here what are the majority charge carriers? In case of P type, the majority charge carriers are holes, whereas in case of N type, the majority charge carriers are electrons. Okay. Now we talk about the dopants. That means the type of impurities that are used to dope. Dopants are trivalent atoms in case of P type, and in case of N type, these are pentavalent atoms. Okay. Pentavalent atom. What is trivalent? It means 3 electrons are present in the outermost shell. Okay, outer shell, and they take part in the chemical reaction. Whereas in case of pentavalent, 5 electrons are present in the outer shell. So we can see that 3 electrons will be less negative as compared to the 5 electrons. Therefore, in P type, the majority carriers are holes and trivalent atoms are used as dopants. So option A will be the correct answer. And here we can see the third one, electrons are the majority carriers and pentavalent atoms are the dopants. It represents the N type semiconductor. Got it? Question number 76 is from the chapter Electromagnetic Induction, and the question is, in which of the following devices the eddy current effect is not used? Options are magnetic braking in train, electromagnet, electric heater and induction furnace. So the correct option will be option number C, that is electric heater. Okay. So what are eddy currents? These are loops of electric current. See, like this, loops, and these are generally produced when both electric as well as magnetic field is present. Okay, so let's write it down here. Eddy currents are loops of electric current, and there are two situations when the eddy currents can be formed. Okay, so the first situation is when there is changing magnetic field. Okay, so these can be produced, these can be induced or produced within conductors by a changing magnetic field. Okay, changing magnetic field. That means if magnetic field is changing within a conductor, then it can cause the eddy currents. Similarly, if there is motion of conductor, then also eddy currents can be induced. Okay, so these can also be induced by relative motion of a conductor in a magnetic field. So you can see that both electric field or the current as well as magnetic field are required here. Okay, but in first case magnetic field is changing, and in the second case conductor is moving. Okay, so in both the cases eddy currents will be produced. So in the first, second and fourth one, that is magnetic braking in train, electromagnet as well as induction furnace, in these three the eddy currents are used. Okay, so here these are used, but in the third one, that is electric heater, eddy currents are not used. Okay, electric heater. Then what is used in this case? Here heating effect is used. Okay, Joule's heating effect. So let's write it down here. It does not involve eddy currents. It uses Joule's heating effect. Okay, so I hope you understood this. Alright, now question number 77 is from the chapter Motion in a Plane. And the question is, the speed of a swimmer in still water is 20 meter per second. The speed of river water is 10 meter per second and is flowing due east. If he is standing on the south bank and wishes to cross the river along the shortest path, then the angle at which he should make his strokes with respect to north is given by. Okay, so let's try to understand the question first. It is given that the river is flowing towards east direction. Okay, so this is the direction of flow of river. This is west, this is east. Okay, and the swimmer is standing at the south bank. So this is north direction, this is south. So he is standing somewhere here. Okay, now he has to cross the river by covering the shortest path, right? So we know that the shortest path will be this one. This is point A, this is point B. Then this AB will be the shortest path, right? If he makes any angle with this line, this is the normal. Okay, so if he makes any angle with this normal, then the path will get longer. So we know that whatever path he follows will be shifted towards right slightly due to the motion of river water towards right. Okay, it is moving towards east, that means towards right. So the motion of river will cause slight shift in the path of the swimmer towards right, isn't it? So this will not be the shortest path. That means he should not try to cover this path. Instead, he should start somewhere like this, so that after getting shifted towards right, he ends up covering the shortest path. Got it? That means he should make his strokes towards left side, okay, at certain angle theta. Now we have to find out this angle theta, okay. So we know that this is the direction of river flow. So let's assume that this is VR, that means velocity of river, okay. Now the swimmer is moving towards this side, so it is vector Vs, that means velocity of swimmer, and this is the shortest path AB. So let's write it down here, vector Vx, okay. Now we know that vector Vx will be the vector sum of these two. That means vector r plus vector s. Okay. That means sine theta will be equal to vector r divided by vector s. Now what is the speed of river? It is 10 meter per second. So if we put the value 10 divided by the velocity of the swimmer, that is 20 meter per second. So here we get half. Sine theta is half, that means theta is sine inverse of half. So what will we get here? 30 degree. Okay, sine 30 degree is equal to half. That means this theta is 30 degree, and this is with this 30 degree is formed with this normal, right? That means option number D will be the correct answer, 30 degree west. That means it moves slightly west, making an angle 30 degree with this normal. Okay, so option D will be the correct answer. Question number 78 is from the chapter Mechanical Properties of Solids, and the question is, when a block of mass capital M is suspended by a long wire of length capital L, the length of the wire becomes capital L plus small l. The elastic potential energy stored in the extended wire is, okay. So what is given here? We have a long wire of length capital L. Suppose this is the wire, this is length L, and suppose the area of cross section is capital A, okay. Now it gets extended or gets elongated such that the new length becomes capital L plus small l, okay. That means the extension is small l. Now at the end of this wire, a block of mass capital M is suspended. What we have to find out? We have to find out the elastic potential energy stored in the extended wire, okay. So we know that the energy stored per unit volume, is equal to half into stress into strain of the wire. So what is stress? Stress is equal to force per unit area, okay. So force will be this weight of this block, that means mg, okay, and area will be A, okay. A is a cross-sectional area. What is strain? Strain is the change in length per unit original length, okay. That means small l, this is the change in length, and the original length was capital L, okay. So this is the energy per unit volume. Now we know that area into length, this is area and this is length. So area into length will be what? Volume. So we can write it like this, half mg L divided by volume, okay. A into capital L will be the initial volume of the wire. And this side also we have energy per unit volume. So volume will get cancelled. So what will be left? Half mg small l, okay. So this is equal to the elastic potential energy stored in the extended wire. That means option B will be the correct answer, not C, because it has capital L and we have small l here, okay. So option B will be the correct answer. Question number 79 is related to current electricity, and the question is, in the circuits shown below, the readings of voltmeters and ammeters will be, okay. So we have two circuits here. This is circuit number 1, this is circuit number 2, okay. Then we have the voltmeters V1 and V2 and ammeters A1 and A2 respectively, okay. So let's assume that the voltmeters as well as ammeters are of ideal nature, okay. So we know that for an ideal voltmeter, what will be the resistance? Resistance is equal to infinity, okay. That means infinite resistance is there. And what does this mean? It means that no current will be able to pass through this voltmeter, okay. So no current can pass. Similarly, for an ideal ammeter, what will be the resistance? This time the resistance is 0, okay, for an ideal ammeter. That means all the current will be able to pass through these ammeters A1 and A2. Okay. Now what is the difference between the first circuit and the second circuit? The difference is the presence of additional this 10 ohm resistance, right? So this 10 ohm resistance is actually useless because this V2 has infinite resistance. That means no current will be able to pass through this segment. Okay, this complete segment, no current will be passed. That means this 10 ohm resistance has no role to play here. Okay, so then it both the circuits become same, isn't it? Because both have same 10 ohm resistances and 10 volt potential, right? So let's try to find out the currents I1 and I2. I1 will be what? Potential difference divided by resistance. So V is 10 volt and the resistance is 10 ohm. So the current will be 1 ampere. Okay. Similarly, I2 will be V by R. Here also V is 10 volt and the resistance is 10 ohm. So 1 ampere current is there. Okay, because both are now same. Okay, so the current will also be same, the potential difference will also be same. Okay, still let's find out potential difference is what? I1 into R. I1 is 1 ampere, R is 10 ohm, so it will be 10 volt. Okay, similarly here also this is V1, right? And now in the second one V2 will be equal to I2 into R. So I2 is also 1 ampere and R is 10 ohm. So again we get 10 volt. That means V1 and V2 are same and I1 and I2 are also same. Okay. So which expression will be the correct one? Option number B will be correct. V1 equals to V2 and I1 equals to I2. Question number 80 is from the chapter Systems of Particles and Rotational Motion, and the question is body A of mass 4m moving with speed u collides with another body B of mass 2m at rest. The collision is head-on and elastic in nature. After the collision, the fraction of energy lost by the colliding body A is, okay. So we have to find out the fractional loss of kinetic energy and we have a direct formula for that. What is given in the question? M1 is given as 4m and M2 is given as 2m. Now merely on the basis of masses we can find out the fractional loss. Okay, we don't need the values of speeds. So fractional loss of kinetic energy of colliding body. We are finding the fractional loss of kinetic energy of one colliding body, right? That is body A. So that is delta Ke by Ke is given as 4 m1 m2 divided by m1 plus m2 whole square, right? That means 4 into m1 is 4m, m2 is 2m divided by m1 plus m2, that means 4m plus 2m whole square. So here we get 4 into 4 is 16 into 2 is 32. So 32m square divided by 4 plus 2, that is 6m. So 6m square means 36m square. So m square cancelled. Here we get 8 by 9. Okay. That means this fractional loss is equal to 8 by 9. So option A will be the correct answer. Now question number 81 is related to motion in a plane, and the question is a particle moving with velocity vector v is acted by three forces shown by the vector triangle PQR. The velocity of the particle will be, okay, so this is the triangle. We can see, look at the direction here, okay, so we can see that the forces are forming closed loop in the same order. What does that mean? That means that the net force will be 0, okay, so F net will be 0. That means mass into acceleration will be 0. And what is acceleration? It is rate of change of velocity. That means dv by dt, right? So it means that mass then dv by dt is equal to 0. So what is dv by dt? dv by dt is also 0. Okay. So the rate of change of velocity is 0. That means there is no change in velocity. That means velocity remains constant. Okay. So rate of change of velocity is 0. That means velocity does not change. Okay. Does not change. That means velocity remains constant. Okay. So option B will be the correct answer. Question number 82 is from simple harmonic motion, and the question is the radius of circle, the period of revolution, initial position and sense of revolution are indicated in the figure. Y, that is the projection of radius vector of rotating particle P, is. Okay, so we have to determine the value of Y here. Now if you look at this figure, you can see that time period is given as 4 seconds. So T is equal to 4 seconds. Then what will be the value of omega? Omega is equal to 2 pi by T, that is 2 pi by 4. Okay, so here we get pi by 2 and the unit for omega will be radian per second. So we have got the value of omega. Now if you look at this figure, you can see that at t equals to 0, the value of y is maximum. Okay, so let's write it down here. At t equals to 0, the displacement y is maximum. That means the value of y will be equal to a cos omega t. That is a cosine function. What is the value of a? A is equal to 3 meter, same as the radius. So a is 3, cos omega is pi by 2 radian per second. So pi by 2 into t. Okay. So here, which is the correct expression? Y is at time t. Okay. So yt equals to 3 cos pi by 2t. That means option C. Y is in meter. Okay. So option C will be the correct answer. Question number 83 is from the chapter Systems of Particles and Rotational Motion, and the question is a solid cylinder of mass 2 kg and radius 4 cm is rotating about its axis at the rate of 3 rpm. The torque required to stop after 2 pi revolutions is. Okay, so we have to calculate the torque, and torque, that is tau, is equal to moment of inertia I into angular acceleration alpha. Okay, so in order to calculate the torque, we should know the value of moment of inertia as well as angular acceleration. Okay, so let's find out the moment of inertia first. Moment of inertia for a solid cylinder which is rotating about its axis is equal to mr square by 2. Okay, so mass is given as 2 kg into radius is 4 centimeter, so it can be written as 4 into 10 to the power minus 2 meter. Okay, so 4 into 10 to the power minus 2 square divided by 2. So 2 cancelled. What is left here? 4 square, that means 16, and then 10 to the power minus 4. So this is your moment of inertia. Now we have to calculate angular acceleration. Okay, so we know that for linear motion, we use the expression v square equals to u square plus 2as. Therefore, for angular motion, we can use the similar expression omega square equals to omega naught square plus 2 into alpha into theta. Okay, alpha is the angular acceleration and theta is the angular displacement. Now what is the omega? Omega is the final speed. So this is going to be 0 because this cylinder has to stop after 2 pi revolutions. Okay, so it will stop, that means final speed will be 0. Okay, so let's put the value here, 0 square, that is 0. Now initial speed is given as 3 rpm. So omega naught is given as 3 rpm, and we know that 1 rpm is equal to 2 pi by 60 radian per second. Therefore, for 3 rpm, it will be 2 pi by 60 into 3 radian per second. That means 6 pi by 60 radian per second. Okay, now if we simplify it, we'll get pi by 10 radian per second, right? So the initial speed is pi by 10 radian per second, and we have square, so square, plus 2 into alpha. So alpha is to be calculated here, and theta is the angular displacement. We know that for one revolution, the distance covered is 360 degree. Okay, so for one revolution, theta is equal to 360 degree, that means 2 pi. Okay, so for 2 pi revolution, it will be, theta will be equal to 2 pi into 2 pi. Got it? Therefore in place of theta we'll write 2 pi into 2 pi. So what do we get here? Here we get pi square by 100 plus 2 into 2 into 2, that is 8 pi square alpha. Okay, and this is equal to 0. So here we can write that minus pi square by 100 equals to 8 pi square alpha. So pi square cancelled. Now we have got the value of alpha. Alpha is equal to minus 1 by 800 and the unit is radian per second square. Okay, so now we have got the value of moment of inertia as well as the angular acceleration. So let's find out the torque now. Torque is equal to the product of moment of inertia and angular acceleration. So what was moment of inertia? It was equal to, let's see, what was it? It is 16 into 10 to the power minus 4. Okay, so 16 into 10 to the power minus 4 into alpha is minus 1 by 800. So minus 1 by 800 radian per second square. So let's solve it. Here we get 8 into 100 is 800. 8 into 2 is 16. So 2 into 10 to the power minus 6. Okay, 2 into 10 to the power minus 6. That means option D will be the correct answer. Unit will be Newton meter. Got it? Question number 84 is from the chapter Motion in a Plane, and the question is, two particles A and B are moving in uniform circular motion in concentric circles of radii RA and RB with speed VA and VB respectively. Their time period of rotation is same. Then the ratio of angular speed of A to that of B will be. That means we have to find out the ratio omega A is to omega B. Okay. Now we have two concentric circles. That means if this is center O, then it is the common center for the circular paths of the two particles, particle A and particle B. Got it? Now we have to find out the ratio of angular speed. So what is the formula for angular speed omega? It is equal to 2 pi by t, where t is the time period. Okay. So omega A by omega B will be equal to TB by TA. Okay, because we can see that omega is inversely proportional to T. 2 pi is a constant. Now we know that the time period of A and B are same. It is given in the question. So let's assume that it is T for both. Okay, so it is T by T. That means 1 by 1, right? So the ratio will be 1 is to 1. So option C will be the correct answer. Question number 85 is from the chapter Moving Charges and Magnetism, and the question is, ionized hydrogen atoms and alpha particles with same momenta enters perpendicular to a constant magnetic field capital B. The ratio of their radii of their paths RH is to R alpha will be. Okay, so we have to compare the radii of these two particles, and both are ionized. That means both are charged particles. So for that we should know the formula for radius of charged particle in the presence of magnetic field. Okay, so let's write it down here. Radius of a charged particle in the presence of magnetic field is given as mv by qb. Okay, what is m? M is the mass of the particle, v is the velocity of the particle, q is the charge on the particle, and b is the magnetic field. Okay, now we know that mv is equal to momentum. Okay, this is momentum. Momentum is the product of mass and velocity. So we can write that this radius is equal to momentum divided by the product of charge and magnetic field. Now it is given that both the charged particles have same momenta. That means P is same. Also they have they enter into constant magnetic field capital B. So B is also same. That means radius will depend on the charge or charge on the particle. Okay, so radius is inversely proportional to charge. That means RH by R alpha will be equal to Q alpha divided by QH. Okay, because both are inversely proportional. Okay, and what is the charge on the alpha particle? It is +2, so it will be 2 divided by the charge on a hydrogen is 1. That means this ratio RH is to R alpha is equal to 2 is to 1. Got it? So the correct answer will be option number D. So last option is the correct answer. Question number 86 is from the chapter Motion in a Plane, and the question is, a mass small m is attached to a thin wire and whirled in a vertical circle. The wire is most likely to break when? Option A, the wire is horizontal. Option B, the mass is at the lowest point. Option C, inclined at an angle of 60 degree from vertical. And option D, the mass is at the highest point. Okay, so the correct option is option number B, that is when the mass is at the lowest point. Okay, so the wire is most likely to break at a point where tension in the string is maximum, and it is a known fact that the tension is maximum at the lowest point. Okay, now if we talk about the highest point, then at this point tension is minimum. That means the wire is least likely to break at this point. Okay, now if you want to know the reason, let's have a look at this figure. Suppose this is the circular path of the wire, this is the center, and this is the radius. Okay, now if we want to know the tension in the string at a certain point B, then at this point this is the theta, okay, angle theta. So what will be the value of tension here? Tension is equal to mv square by r plus mg cos theta. Okay, that means this tension depends on this angle theta. Okay, now what happens at the lowest point? At the lowest point, that means at this point A, theta becomes 0 degree. Okay, this is 0 degree here at this point. Therefore, cos theta becomes, cos 0 degree is 1. That means tension is maximum at this point. Okay, now if we talk about the highest point, at the highest point, that means at this point, suppose this is point C. So at this point the angle becomes 180 degree. Okay, so theta is equal to 180 degree here. Therefore cos theta, that means cos 180 degree becomes -1. Okay, -1. Therefore tension is minimum here. Okay, because tension is in negative. So I hope you understood why tension is maximum at the lowest point, and therefore the wire is most likely to break at this point. Okay. Question number 87 is from the chapter Magnetism and Matter, and the question is, at a point A on the Earth's surface, the angle of dip delta is equal to +25 degree. At a point B on the Earth's surface, the angle of dip is equal to -25 degree. So we can interpret that options are A is located in the southern hemisphere and B is located in the northern hemisphere. Second one is A is located in the northern hemisphere and B is located in the southern hemisphere. Third one is both are located in the southern hemisphere, and the last one is both are located in the northern hemisphere. So this is a general concept. See, first of all, what is angle of dip? Angle of dip, that is delta, is the angle between the Earth's resultant magnetic field and the horizontal. Okay, so it is the angle between the Earth's resultant magnetic field and the horizontal surface. Okay, now what is the value of angle of dip? The angle of dip at equator is assumed to be 0. Okay, so at equator angle of dip is 0. Okay, if we talk about the northern hemisphere, then here the angle of dip is said to be positive, whereas in the southern hemisphere, the angle of dip is assumed to be negative. Okay, that means if the at point A the angle is positive, it means it is the northern hemisphere. Okay, and in the second case it is negative, so it is southern hemisphere. Okay, so which option will be the correct one? Option number B. A is located in the northern hemisphere and B is located in the southern hemisphere. So option B will be the correct answer. Let's see the representation of this. In the first case, this is the horizontal pH. This is vertical magnetic field. This is the resultant. Okay. So the resultant makes an angle with the horizontal. This angle is the angle of dip and this is the representation of positive angle of dip. Okay. Similarly, the negative angle of dip can be represented like this. This is horizontal. This is vertical magnetic field. This is the resultant. Okay. And the angle with the horizontal is angle of dip and this is negative. Okay. So I hope you understood this. Question number 88 is from the chapter Wave Optics and the question is, in a double slit experiment, when light of wavelength 400 nanometer was used, the angular width of the first minima formed on a screen placed 1 meter away was found to be 0.2 degree. What will be the angular width of the first minima if the entire experimental apparatus is immersed in water? Okay, refractive index of water is given as 4 by 3. Now it's very simple. What is the formula for angular fringe width? Angular fringe width in air is given as beta by d. Okay, beta is the fringe width. So here in the question, the value of angular fringe width in air is already given. It is 0.2 degree. Okay, so beta by d is equal to 0.2 degree. Okay, now the angular fringe width in water will be the angular fringe width in air divided by the refractive index of water. Okay, so mu naught is equal to b beta by d. So it is beta by mu d. Okay, so what is beta by d? Its value is already given 0.2. So the angular fringe width in water will be equal to 0.2 divided by 4 by 3. Refractive index of water is 4 by 3. 4 and 3 will move up. So here we'll get 0.6 divided by 4. So on dividing we'll get 0.15 degree. Okay. So this is the angular fringe width in water. So option A will be the correct answer. Question number 89 is from the chapter Motion in a Plane and the question is, when an object is shot from the bottom of a long smooth inclined plane kept at an angle 60 degree with the horizontal, it can travel a distance of x1 along the plane. But when the inclination is decreased to 30 degree and the same object is shot with same velocity, it can travel x2 distance, then x1 is to x2 will be. Okay, so it is given that in first case the angle of inclination is 60 degree with the horizontal. Okay, whereas in the second case the angle of inclination of the plane is 30 degree with the horizontal. That means theta 1 is 60 degree and theta 2 is 30 degree. Okay, now here we know that after covering the distance x1 and x2 the object is going to stop. That means x1 and x2 are the stopping distance. Okay, so we should know the formula of stopping distance. It is given as u square by 2g sine theta. Okay, so here we have to find out the ratio of two stopping distances x1 and x2. Okay, so x1 and x2 will be equal to u square by 2g sine theta 1 divided by x2, that means u square by 2g sine theta 2, right? So u square cancel because they have same velocity. Okay, so 2g also cancelled. What is left here? Sine theta 2 by sine theta 1. Okay, now theta 2 is 30 degree, theta 1 is 60 degree. That means sine of 30 degree divided by sine of 60 degree. Now sine 30 degree is equal to half and sine 60 degree is equal to root 3 by 2. Okay, so root 3 and 2 will go up. So it will be 2 cancelled. 1 by root 3. Okay, so the ratio will be 1 is to root 3. That means option B will be the correct answer. And now the last question is from the chapter Simple Harmonic Motion. And the question is average velocity of a particle executing simple harmonic motion in one complete vibration is. Okay. So what does one complete vibration means? It means that the displacement will be 0. Okay. In one complete vibration, displacement is 0. Okay. So what will be the average velocity? Velocity is equal to displacement divided by time, right? Divided by time. So we know that here the displacement, that means y final minus y initial will be 0. So when it is divided by time, whatever the time it will be 0 only. Okay. So option C will be the correct answer. Average velocity of a particle in one complete vibration will be 0. Okay. So here we complete all the physics questions from NEET paper 2019. I hope it was helpful to you. So we'll come back with another session. Till then, keep learning, keep scoring high. For any doubt related to papers, join our Telegram channel. Link is given in description. Also, don't forget to subscribe our YouTube channel. Thank you.